what we are going to do right now is we're going to go over a series of problems, okay, that are going to ensure your success in passing the algebra regents. This is going to be packet number 1. There will be other packages on the way, but right now let's concentrate on this one. As we go, I will give you a detailed explanation of what every symbol means. Alright, for example, these bars right here, the bars, okay? Now you should be taking notes as I go along, okay? These bars, they represent absolute value. But what is absolute value? Absolute value is nothing more than distance. And distance can never be negative. So, for example, the absolute value of -5 is 5. Guess what? The absolute value of 5 is also 5. If you were thinking about -5, you were not paying attention to me. As I was saying that the absolute value of any number is always positive because it measures distance. Alright? So, if I was to tell you, what is the absolute value of -10? What would you say? Exactly, 10. The absolute value of positive 10 is also 10. So, what you are going to do right now is you could pause if you want to copy this, but what you are going to do right now is you're going to grab the calculator, okay? And I am going to show you how to get absolute value on the calculator. Alright? First of all, press math, the key that reads math, and then go to the right, and then you will see something like this, that it says apps. I'm going to show it to you right now. Okay, so for example, I press math, then I'm going to go to the right. You see the word apps right there? You hit enter and you get your 2 little bars. Okay, that's one of the first skills that you're going to learn. So once again, we press math, we go to the right, and you'll see the word apps right there. You hit enter and you get your absolute values. Now, another skill that you need to learn and that is very useful is how to get fractions on this calculator. Well, all you have to do is press you press alpha, the green key, and then the gray key that reads y equals. Alpha, y equals, and then you see n over d. N over d means numerator over denominator. You hit enter, and guess what? You got a fraction right there. So, now, let us see if I can input that first problem into the calculator. But before we do that, let's go back to our problem. Alright, so this is how you get the absolute value. The little bars right there. Which mean that whatever you get is going to be positive. Last but not least, what is this exclamation point right here? Exclamation mark. Well, this exclamation mark right here, 4 factorial. It's read factorial. Factorial. Alright, factorial. 4 factorial is nothing more than 4 times 3 times 2 times 1. If I had the number 5 factorial, it would just mean 5 times 4 times 3 times 2 times 1, which is 120 if you multiply the whole thing. Okay, so you see, these are simple steps, okay, simple topics to learn in order to ensure your success. So now you learn about absolute value, you learn about the little factorial, you learn how to get the absolute value on the calculator. Now I am going to show you how to get the factorial on the calculator. So let me get the calculator. Let's put it right here. Okay. And then to get the factorial, I think you press math and you go all the way to where it says probability. And you go down and you'll see the exclamation mark right there. You see it? Okay, you press enter. Now, of course, let's say we want to do 4 factorial. Then we press 4, then math, go to probability, we go down, and we press enter. You see now we have 4 factorial. Well, press enter again, and 4 factorial is 24. That means 4 times 3 times 2 times 1. Okay then, so now let us enter our first problem in the calculator, now that we have gotten those skills. So let's see, it says absolute value. So I'm going to do absolute value. So I said math, and go to where it says abs. Okay, good. Now, if you look at the first problem, you see that it's a fraction. So I'm going to press alpha y equals. I hope you're following this. And you press enter. Now I have a fraction inside the absolute value. So what am I going to do? Well, I just enter the data. So it says 4 multiplied by -6, okay, plus 18, okay, and then it says over 4 factorial. 4, remember, press math, go all the way here, and choose the factorial. Guess what? Now this looks exactly like what I have on the board. So when I press enter, I end up with 1 over 4. Isn't this a beautiful thing that actually the calculator gives you the answer in the form of a fraction? Well, the answer is 1 over 4. Okay. So let us explain why is the answer 1 over 4. Look, this is what you have. Absolute value of 4 times -6 is -24 plus 18. Right? And that was over 4 factorial. What is 4 factorial? 4 times 3 times 2 times 1. Okay, so let us continue right here. So I have absolute value of, okay, -24 plus 18. What's -24 plus 18? That is -6. So I got my top already solved, my numerator. Okay, and then over 4 times 3 is 12, times 2 is 24, times 1 is 24. So 6 over 24. When you put this on the calculator, when you reduce it, okay, to reduce means to bring the fraction to simplest form. So let's see, can I divide both? Oh, by the way, how do you achieve that? By dividing both the top and the bottom, the numerator and the denominator, by the same number. That's the only way you can reduce a fraction. So can I divide 6 by 6? Yes, of course. So then that gives me -1. 24 divided by 6 is 4. Wait, hold on a second. But this is -1 over 4. But the answer is, the calculator gave us 1 over 4. Of course, I'm forgetting something. The first skill that you learned, that it's within absolute value. So therefore, I said that the absolute value of any number cannot be negative. It's always positive, making your answer 1 over 4. As simple as that. Okay, so you could pause the video, you copy this. Right now, let's do problem number 2. That's the heater, by the way, the radiator. Okay, the value of the expression, and then we have 6 factorial plus 5, a fraction right here, okay, minus 10. So, how are you going to do this on the calculator? Easy. You do 6 factorial. You already learned how to write 6 factorial. Okay? That's a skill that you already acquired. You press the plus sign. Then, you need a fraction. So, with the calculator, you press alpha and the gray key that reads y equals, and the calculator automatically will give you the fraction representation, and you input the data on top. So, Let's see now. 5 factorial on top times, parentheses in the calculator, 3 factorial still on top, right? And in the bottom you have 4 factorial. And not only that, this is minus 10. You see, you gotta make sure that you move over in order to put the minus and the 10. Well, what is 6 factorial? I have no idea. So let's see if we could do it. We could do this. I'm gonna do a step by step. So let's see. 6 factorial. So 6, math, move all the way to probability, go down to factorial. Okay, 6 factorial. Then plus, and now I need alpha y equals, because I need a fraction. Then on top, I'm going to put 5 factorial, which you already know because you already acquired that skill. Parentheses, which means multiplication, 3 factorial. Okay, now close the parentheses. Now you're going to go down and we need 4 factorial. Well, we already know what 4 factorial is. 4 and then math, go down, factorial. Guess what? You need to move over. If you don't move over, then everything is going to go under the fraction. So you cannot do that. You don't want that to happen to you. So, okay. So 4 factorial, we move over. You see what happened? And now minus 10, right? See how easy it is? These are easy points. Now you hit enter. 740. Okay? So let us pretend that we don't know. Okay? So let us pretend I need to know what 6 factorial is. 6 factorial is 720. Okay, let me go back to the problem. 6 factorial is 720 plus 5 factorial, which is 120, times 3 factorial, which is 6, right, over 4 factorial, which is 24, minus 10. Okay? This is the other way of doing it. If you want to do it step by step. Okay? Right. So once you do this, you're going to end up with 740. Alright? Good. Now, let us do the next problem. Problem number 3. Okay. You pause, you get this, and it's fine. Alright, remember that this was over 24. I just erased it to make clear what the problem is. Alright, what is the value of the expression, absolute value of this, right? Negative 5x plus 12, when x is 5. Oh my God, this is substitution. They are telling me what the value of x is. So what is the right course of action? They want me to plug this in here. That's exactly what I'm going to do. So I put the absolute value, right? You know how to do that on the calculator already. And then inside the absolute value, I'm supposed to put negative 5x. Negative 5x is the same thing as negative 5 times x. Every time you see a number with a letter, that means that the number gets multiplied with the letter. So this is negative 5 times x. And from now on, whenever you see it like that, just say multiply by or times. So negative 5 times x. But then what is x? 5. Alright. So negative 5x plus 12. And then I close my absolute value because I'm doing it by hand. You have the calculator. You put this on the calculator and you get the correct answer right away. So what is negative 5 times 5? Well, negative 25. And then we move on, we bring down the 12. We're going step by step. Now what is negative 25 plus 12? Well, that is negative 13. what did we say about absolute value? That it measures distance. And distance can never, ever, ever, ever be negative. So the absolute value of negative 13 is positive 13. For those of you who were skeptical and thought that the answer was negative 13. No, the answer is 13. You see that? It's not difficult. Just gotta be careful, just gotta watch out for any minor details. Alright, let us do, let me see if we have time for one more problem. Oh, definitely, this is one problem that we need to address. Problem number 4. The value of the expression negative absolute value of a minus b when a is 7 and b is negative 3. Watch this, because you see it once and you could do the rest. You see it once, you've seen it all. The negative is outside the absolute value. What is the value of a? 7. Minus belongs to the expression that you were given. See that? That's the minus. And b is negative 3. So that's the way you write it. Why am I making this clarification? Because as a student, you tend to forget about this minus and you just write minus 3. So in other words, if you were thinking like the way I'm saying right now, you would have written absolute value of 7 minus 3, which that would be completely wrong. It's 7 minus negative 3. Okay then. So let's see what is the evolution of this. So negative absolute value of 7 minus negative 3. Minus negative, minus negative, minus negative. I hate to see two signs like that. So what are you going to do? Multiply the signs, always. So negative times negative is positive. So in reality, this is nothing more than 7 plus 3. Oh, interesting. Because 7 plus 3 is 10. Now, what's so peculiar about this? That the absolute value of 10 is 10. But there is a negative sign waiting for the 10. Whatever comes out of here is going to be positive. Whatever comes out of this absolute value. But there is a negative waiting outside the absolute value. Therefore, whatever comes out has to be multiplied by a negative. So positive 10 times negative gives you a negative 10, making the answer number 1. Think of it this way. Whatever happens in school is controlled, right, by our actions. And you know you're safe here. But if there is a gang or whatever waiting to jump you outside the school, there is whatever comes, you're gonna come out of here safe. But as soon as you step out, something might happen. Same thing here. Yes, the 10 is safe right here. It's gonna come out positive. We know this. But there is a negative waiting somewhere outside the building. Therefore, it has to become negative. Alright, on the next session, we're going to continue with these problems, okay? This is problem, we did 4 problems from packet number 1. We're going to continue with these problems later, okay? Thank you. Okay, now we are on to problem number 5. It says, if x equals negative 3, what is the value of absolute value? The bars mean absolute value, okay, of x minus 4, and then outside the absolute value we have minus x squared. Well, let's see what happens. We're going to do it by hand first. So absolute value of x, but then again, what is x? We were given the x, it's minus 3 or negative 3. Okay, so that's exactly what I'm going to do. See, negative 3 and then minus 4. Close the absolute value, then we put minus, and then we have x is negative 3, but I have x squared. So it's going to be negative 3 squared. Now notice something. Some of you might tend to write minus like this. Minus negative 3 squared. You can't do that. Remember, you are squaring the whole negative 3. Now I'm going to explain to you why. If you put negative 3 squared on the calculator, you're telling the calculator, or you're telling yourself, square 3, which is 9, and then make it negative. That's exactly what you're saying. But if you put parentheses around the number, what you are saying is the following. Take negative 3 and square it. And in other words, you are saying this. Negative 3 times negative 3, which in this case is positive 9. Understand the difference? So make sure, okay, just for the sake of doing it, make sure that every time you have something square, you put that something in parentheses. Alright? So now we are ready to start solving the problem. Make sure you take notes. If you need to pause this, you pause it and that's it. Alright. So negative 3 minus 4 is what? Well, when you have two numbers with the same sign, you add the numbers and keep the sign. Or think of it as losing points or spending money. If you spend $3 and now you spend $4, you spent $7. Okay? Minus this quantity squared, which is positive 9, but this minus comes from here. Alright? So now let's see what happens. What is the absolute value of negative 7? Well, we discussed that the absolute value measures distance, and distance can only be positive. So the absolute value of negative 7 is positive 7. So this is positive 7 minus 9. What is 7 minus 9? If you don't know, use the calculator. And that's negative 2. The answer is choice number 2. Alright then. Now let's see if we can do this on the calculator. So you grab the calculator as I go, okay? And remember something. Let's see what we're going to input in the calculator. We clear everything. And let's see, we have absolute value. So how do I get absolute value? Well, press math, go to the right, and you press enter. Notice that my absolute value looks totally different than the one in your calculator because I am using an older version of the calculator. You have the TI-84, I'm using the TI-83. But it's the same concept. So instead of the bars, the calculator gives me parentheses. So, absolute value of what? Of negative 3 minus 4, right? Then close the absolute value, which is a parenthesis. You don't have to close it because you already have the two bars right there. Okay, absolute value of 3 minus 4, minus, and then remember what I said, negative 3 squared. So, put parentheses in negative 3 squared. Let's see what that gives me. Negative 2. Negative 2. So it works with the calculator. Very good. Excellent. Alright then, so then now we can move on to the next problem. Alright, the next problem. Here, a bit tricky, not really. Watch this. Let's write the syntax. The syntax will be the following. Negative 3 times, okay, every time you have a number and a letter, you read it like this. 3 times x. Okay? 58 times p. 60 multiplied by m. Alright? Don't just say 3x, 58p. No. Think of multiplication. 3 times x, 58 times p. Okay? You can rewind it if you want to learn again, if you want to listen to it again. So let's write the syntax now. Negative 3 times x squared. Remember when I said that when you're going to put it, raise it to a power, put parentheses. Okay? So x squared. Okay. What is x? X is negative 4. So I am going to square that. Times y. What is y? Y is 2. Plus 4 times x. What is x? Negative 4. Okay, good. This is the syntax. So what am I going to do? Well, let me do it by hand and then we'll do it on the calculator. So first we do exponents. So I have negative 3 times negative 4 squared means negative 4 times negative 4. So that is 16 times 2 plus 4 times negative 4 is negative 16. Okay. Now negative 3 times 16 is negative 48. Negative 48 times 2 is negative 96. Now I hate to see two signs together. I really hate to see two signs. It confuses me. So what I suggest is multiply the symbols, these signs, and get one single sign. So positive times negative is negative. Okay, negative 16. So now the way you read this is negative 96 minus 16, which is when you have two numbers with the same sign and you are adding them, you add the numbers. So you get negative 112. Alright, let's check with the calculator because that's why you have calculators. So that's exactly what I'm going to put in there. I'm going to put, okay, the syntax was the following. This was the original syntax. So it's going to be negative 3, parenthesis, negative 4 squared, right, times 2, parenthesis also denotes multiplication, plus 4 times negative 4. That's my syntax. That's exactly what I understood when I was given the problem. Enter. Good day, look at this. Oh my God, negative 112. So the correct choice is choice number 1. Good. Alright, so you can pause this. And now we move on to the next problem. Here you are going to learn a new skill, okay? You're going to acquire new knowledge. How is that? Well, we have been presented with new skills. So, before we start, do me a favor and raise 3 to the 0, type 4 to the 0, 5 to the 0, x to the 0. Now, if you don't know how to write this on the calculator, I'll show you right now. Okay? 3 to the 0, 3. You see this little thing right here is called a caret. And you press that button right here. See, 3 to the, and you have the 3 to the 0. That is 3 to the 0. On your calculator, it's gonna look a little more friendly than it looks right here. So 3 to the 0. If you want to put 5 to the 0, you put 5 caret 0. If you want to put x, then you put x caret 0. See that? X is right here. Anyway, you tell me what you get, and then we make a conjecture. We make a conclusion. Okay? That any number raised to the power of 0 is, and you tell me. 1. Excellent. Any number raised to the power of 0, oops. Sorry, let me see, I cannot do x. Alright, so we don't do x, just do the numbers. Let's see, 3 to the 0. 1. 5 to the 0. 1, yes, any number raised to the power of 0 is 1. So now, I'm ready to solve my problem. You just acquire a new skill. The new skill is called that every number raised to the power of 0 is 1. So what we're going to do is this. Alright. This parenthesis is for the expression. See that? Now, a is negative 2. So I'm going to need, remember when I said when you're going to raise a number to a power, put parentheses, then these parentheses are going to belong to the a. So negative 2 to the third power. Plus, okay. And now b. What is b? b is 4. and we're going to raise it to the 0 power. And the whole thing gets raised to the 2nd power. All right then. So let's do the math. Negative 2 to the 3rd power. Well, you could use the calculator and do this. So you get negative 2 times negative 2 times negative 2, which is negative 8. Plus, guess what 4 to the 0 is? What is 4 to the 0?
1.
Excellent. Because we just learned this new skill. It was acquired. So 1. And everything gets squared. Alright. So now, what is negative 8 plus 1? Well, negative 8 plus 1. Which number is greater? Well, 8 is greater than 1. So since 8 is negative, we're going to keep the sign of the largest number. Or another way of saying this is the following. You owe $8. You pay $1. You still owe $7. Or you lost 8 points and you get back 1. You still lost, what? 7. You still owe 7 points. Alright. Negative 7 squared. What does it mean? It means negative 7 times negative 7, which is 49. So you get 49 right here. Now, of course, Mr. Becker, can we do this on the calculator? Of course we can do it. So, let's do this. Let's do it on the calculator. A is negative 2. Watch this. This is the red parenthesis. That means that I have to open another parenthesis. So, negative 2 to the 3rd power, okay, plus 4 to the 0 power, and now, I'm sorry, not to the 1st, to the 0 power, good. Now I'm going to close this red parenthesis, and I'm going to raise it to the 2nd power. Let's see what we get. Haha, good day, we get 49. See that? We get 49, so it's good. Excellent. Alright, let us move on to our next problem. Properties. Finally, we get properties. Alright, so this is what happens. My son comes to me and says, Dad, 2 times 3 is 6. I'm like, wow, good job. That's nothing. 3 times 2 is also 6. Wow, okay. Then 5 minutes later, he comes and he says, 5 plus 2 is 7. Okay, good. Aha! And 2 plus 5 is 7. I'm like, you know what? Okay, fine. Thank you very much. So then after a while, I had to tell him, you just learned the commutative property of numbers, okay? It doesn't matter how you do 2 numbers, what operation you do with 2 numbers, you're still gonna get the same answer. We're talking about multiplication and addition, okay? So then, let us review the 3 most important properties. And you should be taking notes. Commutative property. It says that if you have 2 numbers, A and B, the order in which you add them does not matter. You're still going to get the same answer. 3 plus 2 is the same thing as 2 plus 3. Guess what? This commutative property exists for addition, and it also exists for multiplication. A times B is the same thing as B times A. Notice that I use the asterisk and I use the parenthesis. So, as a way of telling you, it's the same thing. They're both multiplication. Cool. There is another property. It's called the associative property. The associative property, well, that deals with 3 numbers. I don't know, A, B, and C equals A, B, and C. What this property says is that it doesn't matter, let's say you are adding the numbers, okay? It says, well, you know a plain sight that a plus b plus c should be equal to a plus b plus c. Of course it is true. But what the associative property says that it doesn't matter how you group the numbers. The answer is still going to be the same. Well, you saw it without parentheses, so what difference do the parentheses make? Nothing. The only thing is that now you're doing something first. So, how do you read this? A plus b plus c equals to a plus b plus c. Just like English, just like in grammar, there are punctuation symbols, okay? Now, let's try it with numbers. Okay, let's try it with numbers. Give me a number for A.
7.
7 plus, give me a number for B.
3.
3
plus 5.
Plus 5, okay, perfect. And now, remember, we still have the same numbers, but now we're grouping them in a different way. So A plus B, so A is 7 plus 3, and then plus C, which is 5. Okay, let's see if what they told us is true, holds true. So, 7 plus, now what is this? 3 plus 5 is what?
8.
8, very good. So we have 7 plus 8. Okay? And here we have what? 7 plus 3 is what?
10.
10 plus 5. 7 plus 8 is 15. 10 plus 5 is 15. Of course it does. Okay, it holds true. Alright, now guess what? There is an associative property of addition, and there is also an associative property of multiplication. In other words, A times B times C is the same thing as A times B times C. Okay, cool. Now let's discuss the last important property. The last important property is the distributive property. Okay, the distributive property, it looks like this. Now let's use x. Okay. X times A plus B equals to x times A, we go in alphabetical order, is AX. Positive times positive is positive. X times B is BX, the Bronx. Okay. Distributive property is the only property that doesn't have a distributive property for addition and distributive property for multiplication, because it combines both operations at the same time. Notice that you were multiplying here, and then you end up adding, and then you again multiply. Alright, let's say you don't remember this on the test, on the regents. And they ask you, this is an example of what property? Well, let us see a plain sight, okay? What is the difference between each property? Okay, the commutative property doesn't have any parentheses. See that? And it says that the order doesn't matter. Alright, now let's talk about the associative property and the distributive property. So let's see. The associative property has parentheses on both sides. Not just that, but look at the order. A, B, C. A, B, C. The order doesn't change. Get it? So it has parentheses on both sides and the order doesn't change. As opposed to the distributive property. Look at the distributive property right here. It only has parentheses on one side. The distributive property only has parentheses on one side. You see that? And then the other side is just the multiplication. So just keep that in mind. Okay, now that we have seen the properties here, oh no, there is one more property that I have to teach you. Okay. Any number plus what gives you back the original number. Now, let's say 5. 5 plus what is 5. Tony plus what is Tony? Exactly, plus 0. Plus 0. When you add 0 to a number, you get back the original number. Okay? Therefore, Tony is your name tag, is your ID, your identity. So therefore, if you add 0 to your identity, you get back your identity. Wait, oh, I know. So then 0 is the identity element of addition. 0 is the identity element of addition. Alright. Guess what? If 5 plus 0 is 5, Tony plus 0 is Tony. Now, let us try to find what is the identity element for multiplication. In other words, 5 times 1 is 5. Tony times what is Tony? If you can figure that out, then you have found the identity element of multiplication. Get that? Alright then. Yes, it is 1. The identity element of multiplication is 1. And I suggest you write it down. The identity element of multiplication equals 1. Okay, now we are ready to start solving our problems. So let's see. Number 8. Which property is illustrated by the equation? And we have this. Think about it. Okay, I'll give you 5 seconds and then we find the answer. Okay, 5 seconds is up. A times x is ax. A times y is ay. It involves multiplication and addition. Therefore, it has to be the distributive property. Oops. Okay, fine. So, that is the distributive property. Alright. Number 9. The statement 2 plus 0 is an example of the use of which property of real numbers. Look at your properties, take 5 seconds, and tell me what could be the answer. Well, watch this. When you added 0 to 5, you got 5. When you added 0 to Tony, you got Tony. And we said that 0 is the identity element of addition. Therefore, number 9 should be the additive identity. See that? Number 10. The equation 3 times 4 is equal to 4 times 3. Daddy, 2 times 3 is 6. And 3 times 2 is 6. What was it again? Commutative property. Number 11. A method for solving this equation, okay? Identify the properties used to obtain each of the 2 indicated steps. That's easy. First of all, you have parentheses, right? And then look at this. It's multiplying. So, distributive property. Okay. And then it moved the terms around. Yes, you could say combining like terms, but unfortunately they are asking us for a property. So this has to be the commutative property. Don't worry about this question. It rarely appears on the regions. Actually, it's the only question that has appeared in, I don't know how many regions, like 20 regions, algebra regions. So don't pay much mind to this one. Alright then. So now, let's talk about this. Additive inverse. Okay, now you're about to acquire a new skill. Okay, the new skill, the additive inverse. Additive inverse means add the opposite. 5 plus -5 is 0. This is the opposite of this. When you add the opposite, you get 0. which is the identity element of addition. Let's see, what is the additive inverse of negative 10? Well, that will be positive 10. The additive inverse of 2x, well, that will be negative 2x. See that? That's how they cancel out. Now, the additive inverse of x plus y is not x minus y. Okay? These are two different numbers. You are just changing the sign. That cannot be true. Watch this. I'm going to show you right now. The additive inverse of x plus y, well, work individually. What is the additive inverse of x? What is the additive inverse of y? See what the difference was? Okay? So then, you tell me, what is the additive inverse of a minus b? A minus b. Remember, treat them individually. So, what is the additive inverse of A? What is the additive inverse of B? So you have negative A plus B. Okay? Watch out, they're going to try to trick you on the regions. So negative A plus B. Oops. So choice number 3. Which statement illustrates the additive identity? Additive identity. What is the identity element of addition? Right, 0. So which of these has 0 been added? By the way, this would be additive inverse, this would be distributive property, and this would be, let me see, 463, this would be associative property. Okay, which equation illustrates the associative property? What did I tell you about plain sight? Okay, you don't even have to know how to do it, just have to see at plain sight what are the characteristics of the associative property. Can this be the associative property? No. Remember, it has to have what? Parentheses on both sides. Oh, wait. Oh my God, it's obvious. Now watch out. Does it keep the same order? Let's see. X, Y, Z. X, Y, Z. Yes. Perfect. On point. That is your answer right there. (15) Which equation is an example of the use of the associative property of addition? Okay, what do we want? Associative property of addition. What do I know about associative property? It has parentheses on both sides. So it's either choice 3 or choice 4. What other characteristic I said about the associative property? The elements must be in the same order. Let's see. X, Y, 3. X, Y, 3. Okay, I think this is the answer. But let's check with the other one. 3, X, Y. X, Y, 3. They're not in the same chronological order. Therefore, our answer is choice number 3. Perform the indicated operation and state the name of the property. Operation, well, let's see, negative 6 times A is negative 6A. Negative 6 times negative 7 is, negative times negative is positive. 6 times 7 is 42. Okay, so we're getting somewhere, right? Cool, excellent. Oh, wait, this is only half the points. Yes, the property used is the distributive property. Distributive property, we got it. All right, we're awesome. All right, so now, let's stop for now, and on the next video, I'll show you the next problems. So, problem 17 on packet number 1. So remember what I said, this is going to help you pass the regents. I promise you, okay? It's not even a hypothesis. Question 17. Once again, we are going to acquire new skills, new knowledge. Watch this. It says, which interval notation represents a set of all numbers from 2 through 7 inclusive? Oh, wait, what is that? Don't worry about this. All you need to know is the following. Parentheses represent excluded, meaning not included. Ah, nice. And of course you should be writing these down, you should be taking notes. Brackets represent included. Okay, what else? The less than and the greater than also represent excluded. The less than or equal to and the greater than or equal to represent inclusion. That's all you need to know, okay? So write it down because I'm about to erase it. Good. So let's see. I'm just going to erase this part. I think I have enough space. So which interval notation represents the set of all numbers from 2 through 7 inclusive? Is 2 included? Did they say from 2? Yes. So I'm going to write a set. 2, 3, 4, 5, 6. Is 7 included? What do you think?
Yes.
Why?
It says inclusive.
Okay. So then we got our set. Now look at the choices right here. They all are written in the form of 2, 7. So that's exactly what I'm going to do, 2, 7. Now, was the 2 included?
Yes.
So what am I going to use, brackets or parentheses?
Brackets.
Is the 7 included?
Yes.
So what am I going to use, brackets or parentheses?
Brackets.
Therefore, making our choice number
4.
Excellent. Which interval notation represents the set of all numbers greater than or equal to 5 and less than 12? Greater than or equal to 5. Okay, first of all, let me write the set. Greater than or equal to 5. Can the numbers be equal to 5?
Yes.
Of course, they're all, because it says or equal. Okay, so 5 is included, and then 6, 7, 8, 9, 10, 11. Is 12 included? Let's see. It says less than 12. Is 12 less than 12?
No.
So can the number be 12?
It's not included.
So 12 is not included. Okay. So now look at the choices. They are all written as 5, 12. So that's exactly what I'm going to do. 5, 12. Was 5 included?
Yes.
So what am I going to use? Brackets or parentheses?
Bracket.
Was 12 included?
No.
So what am I going to use? Brackets or parentheses?
Parentheses.
Therefore, making our choice number
1.
Number uno. Very good. Number 1. Okay. Number 19. Which interval notation represents the set of all real numbers greater than 2 and less than or equal to 20? Wait. Let me rephrase that. Let me read it slowly. Greater than 2. A number greater than 2. Is 2 greater than 2? No, right? So this number cannot be 2. Therefore, the number 2 is not included. So 2 is not included. Okay, so I write 3, 4, 5, 6, 7. You don't have to write all the numbers. Let it just go all the way to. And 19. Is 20 included? Well, let's see. It says less than or equal to 20. Or equal. Can it be 20?
Yes, sir.
So then I should include 20 in my quest. Now, let's see, the choices are 2 and 20, right? 2 comma 20. Was 2 included?
No.
Was 20 included?
Yes, bracket.
Excellent. All right. Let's see. Interval notation. The set of all real numbers greater than -6 and less than or equal to 14 is represented by. Well, I'm going to leave this up to you so I can move on to the next problem. All right. Excellent. About to learn another skill. This is what you have. 1 less than or equal to x less than 10. I don't understand this. This is gibberish to me. Okay? 1 less than or equal to x less than 10, that's gibberish. Can I say maybe that x is greater than or equal to 1 and less than 10? That's still confusing to me. Wait, I got it. What about if I say that x is all the numbers between 1 and 10? Is that better for you?
Yes.
Alright then. So x is all the numbers between 1 and 10. Now watch this. Let me write that set. Between 1 and 10. X is greater than or equal, or you could say 1 is less than or equal to x. Is 1 included in my set? How do you know that? Because it has the or equal to. So yes, 1 is going to be included because of this or equal to. That means that this number can actually be a 1 because of this or equal to. Okay? So 1, 2, 3, 4, 5, 8, and I could have just written these numbers. 9. Is 10 included? Well, do you see an or equal to?
No.
No. X is less than 10. X cannot be 10. So that's it. It's over. So is 1 included?
Yes.
So I'm going to use brackets. So it's the choice is either 1 or 3. It's 10 included?
No.
No. So it has to be parentheses. So choice number 3. All right. Once again, which interval notation represents, and now I'm going to read it in the simplest form. Okay? I'm going to give it to you the simplest I can. X is all the numbers between -3 and +3. Make sense? Alright. And right away, right off the bat, I'm going to ask you something. Is -3 included here?
Yes.
Yes, because of the or equal to. Okay, you know what? Let me write it down so you can see it larger. So -3 is included. Okay. Was 3 included? Is 3 included?
Yes, sir.
It has the or equal to. So there goes our answer. You choose the right choice. Once again, here, by now you should become used to this. You should be used to this type of problems. So let's see if we understand this problem. Is -2 included?
Yes.
Yes, it is included because it has the or equal to, right? Okay. So -2 is included. Well, -2 is included right here and right here. Okay. Is 3 included?
Yes. Yes, sir.
Yes, sir, it is included. So that makes my correct choice number 4. All right. Now let's talk about this. I need something written in set notation that is equivalent to this set right here. All right. So let's see. I need 1 and I need 4. I need 1 to be included and I need 4 to be included. So let's see if we can do this. Is 1 included here?
No.
No, because it doesn't have the or equal to. So it cannot be choice 1. Is 1 included here?
Yes.
Well, let's see. X is all the numbers between 0 and 4. 0 is not included, so the next number is 1. Then 2, then 3. 4 is not included. So this doesn't look nothing like the original. It's missing the 4. So this cannot be the answer. Alright, now let's use our superior reasoning and let's see what happens. Is 1 included here?
Yes.
Is 4 included here?
Yes.
So then this is our correct choice. Now, you might be confused because they give you a 0, but 0 is the one that is not included. But after 0, remember, X is all the numbers between 0 and 4. So not including 0, but including 4. So that would be 1, 2, 3, 4. Alright? Let's see. Okay. Number 25. The set 11, 12 is equivalent to. And then we look at our choices. And we say X is a number between, X represents all the numbers between 11 and 12. Is 11 included here? No, because it doesn't have the or equal to. Just by the fact that 11 is not included, then this cannot be our answer because we need 11 and 12 to be included. So that is not our answer. Is 11 included here?
Nope.
So then that is not our answer. Is 11 included here?
Yeah.
But we have a problem because not only 11 is included, but look at this. 10 is also included. That means that I will have a set something like this. Because 12 is not included. So 11 and 12, 10 and 11. And that does not look like the original. Alright then, yes, we know the obvious choice, but let's see why. Is 10 included?
No.
No, but we don't need a 10. But after 10, we got 11. Is 11 included?
Yes.
Yes. And is 12 included?
Yes.
Therefore, we found our correct answer. Alright, let's see now. How many more problems we have? 26, 27, 28. Okay, we're going to continue with this on the next episode of how to pass the regions. Okie dokie. So, once again, welcome back to another episode of how to pass your regions, of course. So, we were talking about set notation. So here we have problem 26. Which set builder notation describes the given set? Alright, let's talk about it. Remember what we said here. X is a number between -3 and 2. 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 The key to the solution here is to figure out which ones are included and which ones are not. Is -3 included here? Yes. Do I need -3? Yes. So this could be one of the solutions. Okay. Is 3 included here? No. So I don't need it. Is 3 included here? No. I mean -3, of course. Is -3 included here? Yes. So this could be another possible solution. Now I need 2 to be included. Is 2 included here? Of course not. Because it's not or equal to. It's just less than. So then, correct choice is number 4. Awesome. Alright, let's move on. Problem number 27. Which notation describes the set 1, 2, 3? You know what? Let us do something. Alright. Do I need 1 and do I need 3? Yes. Is 1 included here? Yes. Okay. Is 1 included here? Come on. Okay. Yes. Is 1 included here? No. Is 1 included here? Yes. But guess what? 0 is also included because of the or equal to. So now I need 3 to be included. Is 3 included here? Right, no. If it was included, it would have the or equal to. But guess what? It doesn't have it. So then let's go to the next choice. Is 3 included here? Ah, OD. Awesome. You're a beastie. Alright, so let's see now. 28. Which set builder notation describes -2, -1? You get the point. In other words, I need -2 to be included and I need 3 to be included. Is -3 included here? Yes. Do I need -3? No. Is -3 included here? No. But then we have -2, -1, 0, 1, 2, 3. So in other words, if I was to write this set right here, this would be what? Between -3 and 4, not including -3, right? But including 4. Does this set look anything like this one? No. Okay then, so that is not my solution. Alright. Is -2 included here? No. Do I need it? Yes. Is -2 included here? Of course it is, because it has the or equal to. So, -2, -1, 0, 1, 2, 3. Is 4 included? No, 4 is not included. So does this set look exactly like the original one? Yes. And of course, we had eliminated already 3 choices. So we got 4. All right. Let's go on to the next problem. All right. Problem number 29. Written in set builder notation, this set is what? Oh, come on. I need 1 and 9 to be included. So just be watchful of this, okay? You could solve this problem on your own and figure out what the answer is. Okay? That's your task. Cool. Let's move on to problem number 30. All right. Guess what? Get ready to acquire a new knowledge, okay? So, this is what we're going to be talking about. Complement. What is complement? Well, put it this way. Is everything that is not on a subset. Okay? In other words, what does B need in order to become U? Well, one strategy of doing this is the following. Cross out everything that you already have. And that will tell you what is it that you need. I need S, I need P, and I need H. Where do I find SPH? HPS, SPH, really doesn't matter. The letters are the same. So, voila. Okay then. So let's see if we understood the concept. Problem 31. What is the complement of set B? First of all, we are looking for a subset. This is subset. The subset is B. We got this, the small. Now the complement, again, let me see if I can say it in a different way. The complement of B is everything that B needs to become U. In other words, what is it that I need, what do I need here to become this? Well, as I said before, the strategy is to cross out everything that you already have in order to figure out what you need. So I have 2, I have 3, I have 5, I have 6. That's it. So then what is it that I need? I need 1, I need 4, I need 7, and I need 8 in here in order for them to be the same. So 1, 4, 7, 8. 1, 4, 7, 8. Okay. Try number 32 on your own now. I'm in pause. Okay, so you did it. Okay, now let's try number 33 on your own. Nah, I help you. Consider the set of integers greater than -2. Okay. What is greater than -2? Tell me. Right. -1, 0, oh wait. And less than 6. Okay, 1, 0, 1, 2, 3, 4, 5, 6. Alright, those are the numbers. That is the set. Now, a subset of this set is the positive. Okay, so let's do a subset. What do you want to call it? Let's call it B. The subset is the set of positive factors of 5. What are the factors of 5? What are the factors of 5? Oh, well. 1 and 5, because 1 times 5 is 5. So these are the factors. Okay then. What is the complement of this subset? What did I say about complement? Everything that I need, and everything that I need here to become this. Okay? What am I missing? Or another way of saying it is all the numbers that are, let's see if I can explain this a little better. The subset, the complement of this, no, that's not the way of saying it. The complement of this is everything that you don't have. Okay? Everything that you need to become the big set. Alright. You know the strategy, you cross out what you have. So then, what is it? What was it that you needed? You need -1, 0, 2, -1, 0, 2, 3, 4. Oh, wait, no. Okay. -2. Oh, first of all, we don't have a -2. So wait. What did I miss? Oh wow, what is it that I missed? 6. But let me see, integers greater than -2 and less than 6. Less than 6, oh my god, 6 is not included. Oh, whoo, okay, so it's -1, 0, 2, 3, 4, so the answer here is boom. I was starting to think that I was going crazy. Alright, so we got our answer. Make sure you take notes, okay? And by the way, I don't know the answers to this, and that's why I'm working them out. If I already knew it, I would be circling them, and then that would not benefit you in any way. 34. Given, and this is the big set, right? All even integers from 2 to 20. Alright. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay? Now, what is the complement of B, right? Within the universe of set A. All they are saying is, what is the complement of B? Well, we cross out what we have in order to figure out what we need. So, 10, 10, 12, 12, 14, 14, 16, 16, 18, 18, and you just figure out what you need. Now listen to me. Me helping you do this problem is not to give you the answer. It's to show you that the hardest part is to understand what this means. Okay? All even integers from 2 to 20 inclusive. You write the numbers. Okay? Don't be lazy. You write the numbers and then you start figuring out what is it that you need to do in order to get the answer. Don't be lazy and don't just look at it and, oh yeah, I know this. No, it doesn't work like that. Okay? I'm wasting my time right now with you because I need every single one of you to pass the regents, the algebra regents. Okay? Alright, good. Let's continue. Once again, you could figure this out, but I'm still going to help you. The universal set is the perfect square integers from 4 to 100. First of all, hold your horses. You're about to learn a new skill. So, perfect squares. What are perfect squares? Numbers that have square roots. For example, does 4 have a square root? Yes, which is 2. Then the next one is 9, the next one is 16, 25, 36, and so on and so forth, right? See that? Okay then. So I said, okay, 4, 9, 16, 25, and 36. Alright, because you can take the square root of each of them. So then that's exactly what I want to do. That's it. Okay, perfect squares. Let's get the universal set. This is A. My first perfect square is 4, not 2, because 2 doesn't have a square root. 4. The next one is 9, 16, 25, 36, 49, what's the next one? 64, 81, 100. Okay? So you cannot see 100. Let me see if I can move it around. No, you cannot move it around, so not a problem. Okay, now you can see it. Excellent. Alright, and the subset B is 16, 36, 49, and 64. Now you find a complement. You see, the easiest thing right now is to find a complement. The most difficult task before was to come up with the perfect squares. So the new skill acquired is, oh, I learned what perfect squares are. Okay? And I know which ones they are from 4 to 100. Excellent. Alright, so you figure out what the complement is. I pause it, you pause it, do it, and you come up with the answer, okay? Alright, problem number 36. All odd integers from 1 through 19. First of all, what is an odd integer? An odd integer is not a prime number and is not an even number. Odd integers are 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 10, and so on and so forth. So all odd integers from 1 through 19. You see that? Excellent. So what is the complement of this? Well, that's up to you guys. You see, I took you to the rough road, okay? I figure out for you what this means. And I did it so you understand. Because the skill here is not about the complement. You already know how to get the complement. It's about you knowing what odd integers are. 1 through 19. So we just did it. Now you cross out whatever you have and to figure out whatever is it that you need. Alright. 37. Fine. This I will definitely help you with. So, 12 players make up a high school basketball team. The team jerseys are numbered 1 through 12. So what am I going to do? I need a visual. So I create 1, 2, 3, 4, 5, 12. All right, I got my jerseys. Then it says, the players wearing the jerseys number 3, 6, 7, and, sorry, 3, I'm gonna do it. 3, 6, 7, 8, and 11 are the only players who start the game. So what? List the complement of this subset. I just gave you the complement, so now you know that is 1, 2, 4, 5, 10, and 12. All right. One thing that is going to help you is to make sure you do the work. This was not a multiple choice question, but guess what? I still show work. Even if it's multiple choice, you still show work. For you, for yourself, like, okay, let me see if what I'm actually bubbling right now is true. So that's exactly what I'm gonna do. And you do it. Now here, your worst enemy, and I'm gonna tell you this because it has been everybody's experience. Your worst enemy is not reading, your worst enemy is not reading the problem. Not even that. Some of you don't even bother to read the problem. Guess what? That's it. You are bound to fail. But if you read the problem, then the next step is to reason with the problem. Analyze what the problem is asking you. And figure out that it's not so difficult after all. Okay? Anyway, let's stop wasting time and let's continue with this rally. Alright. Union. This is the last problem I'm going to do right now. So, watch this. Given A and B, what is the union? Please. Union means everything together. And right now, as I'm saying, everything together, you still don't understand what I'm trying to say. So, I'm going to create a visual for you. Everything together, union. When two people unite, they get married. Now it's called a marriage. And yeah, you know what I mean. So, union. Let's say 3, 4, union, 10, 11. So what is the union? 3, 4, 10, 11. Everything together. Now you get it? Okay then. So what is the union of those sets? Well, that's it. Let's unite them. 2, 3, 4, 6, and look, I got 6 on both. So what? I'm just gonna write it once. 8, 9, 10, 12, and 15. That is my answer. So let's see. 2, 3, 4, 6. Okay, found the answer. So that's what union means, okay? Alright, so next time on how to pass your regents, we're going to continue with the other topics, and I'm going to continue trying to get you to acquire new skills, alright? Good. Welcome to another episode of Passing the Algebra Regents. How do I pass the Algebra Regents? That is your aim. That is your goal, and that's everything, okay? So this is like common core stuff. Given set A, and you got these numbers, and set B, you got these numbers. What is the union? Remember what I said about union? If you got the numbers 1, 2, and you got the numbers 3 and 4, what is the union? The union is 1, 2, 3, 4. Put everything together. That's called unite. Good. So now, let's talk about solving this little problem. What is, oh yes, this represents union, and this represents intersection. All you have to remember is the union. This It's a given that will be intersection. So let's see. Let's unite these little fellows. So I got 2, 3, 4, 5, 7, 8, and 9. All right. So this is your union. 2, 3, 4, 5, 7, 8, 9. Bingo. All right, jackpot. That's your union. Let's go on to problem number 40. Which set represents the intersection of sets A, B, and C? Shown in the diagram below. Listen, there are 2 ways of doing this. Let's do the easy way, but it's a lot more work. First of all, let's understand what the word intersection means. Intersection is everything that is common to everything. What is it that they all share? What is the element or the elements that they all share? Well, let's have 3 circles. 1, 2, 3. Let's call this A, let's call this B, and let's call this C. What are the elements in circle A? This circle right here. What are the elements? Are 1, 3, 4, 2, and 7. Okay. What are the elements in circle B? Okay. We have 3, 8, 2, 5, and 6. Okay. And what are the elements of circle C? Well, we have 2, 4, 5, 6, 7, and 8. So what is the common element right here? Mr. Prater, can you tell me what is the element that they all have in common?
Number 2.
You are awesome, sir.
Thank you.
Number 2. Okay. Now, did I need to do all these to know what the intersection is?
Nope.
Not really. Watch this. When you have 3 circles, this becomes your intersection. Oh, this for this circle for B. This for this circle C. And this for circle A. So guess what? Number 2. Excellento. All right. Oh, the answer, of course. Because you are awesome. Brought to you by Mud Haven High School and all that stuff. Okay. We ready to go to the next problem? Oh my God. Given, problem number 41. Given set A and set B, what is the intersection of these sets? Well, whatever they have in common. Remember that when we were doing complement, we were crossing out things, right? Like for example, you see this right here, goes with this one, right? And this one goes with this. So that's what they have in common. Guess what? When we were doing complements, we were actually crossing out everything they had in common to find what we were missing. Well, now that we are doing intersection, intersection means what is it that we have in common? And we have this in common. So therefore, if you were thinking about this, you're half right. If you're thinking about this, you're half right. If you're thinking about this, you are OD. Awesomely nice. 42. You have 3 sets. Question is, what is the intersection? Well, what is it that they have in common? Do they have 0 in common? No. Do they have 2 in common? Oh yes, look. 2, 2, and 2. Okay, so I got number 2. What else? Do they have 4 in common? This, but not this. Do they have 3 in common? 3, 6? No, so it's just number 2. Alright, So you have three sets again. What is the intersection of the sets? Well, I think by now you should be able to know it. Alright, next problem. Given three sets, what is the intersection? You can do this by yourself. Good. Let's go on to problem 45. Given three sets, what is the intersection? Okay, not union but intersection. Union, intersection. So we're looking for the intersection.
Of R and P.
Of R and P. Oh, these two sets. Thank you.
1, 3,
That's it, right?
yep.
Excellent. Good looks. Which statement or what statement is false? Alright. A united with B and united with C, all three together equals D. Let's see if it's true. D, let's write this. The union of all sets. Let's write the union of all sets. So that will be 1, 2, 3, 4, 5, 6, oh my gosh, 7, 8, 9, 10. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's true, right? But guess what? The question is asking you what statement is false. So we gotta watch out for that. Okay, so that was true. So choice number 1 is not our answer. Let's try the other one. The intersection of A, B, and C. Okay, the intersection, whatever they have in common, sure. Let's see, A, B, and C. They don't have the 1 in common, they don't have the 2 in common, they don't have the 3 in common, they don't have the 4 in common, they don't have the 5 in common, they don't have the 7 in common, they don't have the 8 in, they have nothing in common. So the intersection will be the empty set. Oh yeah, that's what it says. These cannot be the answer then. Alright, so then let's try something else. The union of A and C. The union of A and C. Let's see. 1, 2, 3, 5, 7, and 9. 1, 2, 3, 5, 7. Ah, this is not true. Look, this is the union. It's not this one. So right now, this becomes my answer because they are looking for the statement that is false, the one that is incorrect. This is incorrect. So here we go. All right, let's move on to our next problem in how to succeed on the algebra regions. All right. Maureen tracks the range of outdoor temperatures over 3 days. She records the following information. This is the intersection right there. Okay, and she records the information. It says, the question says, express the intersection of the 3 sets as an inequality in terms of temperature T. Get ready to learn a new skill. Remember when I spoke about having the numbers 2 less than x less than 5? And we said that x was a number between x represented all the numbers from 2 to 5, and then we were looking at 2 to see if it was included. And since this number, this symbol, the less than, didn't have an or equal to, then it was not included, and this 5 is not included. But if they had this little or equal to, then they would be included. Well, that's exactly what they want us to do. Because now this, my friends, is what we call an inequality. And not just that, it's a compound inequality. Okay? A regular inequality is just x less than 5. Oh no, we have 2 inequalities joined together. See, this is one right here, and this is another one. Alright then. So now that we have learned that this is an inequality, a compound inequality, then we could go right ahead and mark the intersection, okay? And hopefully you learn and you will reason fairly on future problems that are of this magnitude. For example, let's take a look at the intersection. Intersection is whatever they have in common. So, do all temperatures reach negative 23 degrees?
No.
No. Do all temperatures reach negative 20?
No.
No, because this one stops at 0. But, in order for you to go from 45 to negative 23, do you have to go to 0?
Yep.
In order for you to go from 40 to negative 20, do you have to pass through 0?
Yes.
So then, this is your first intersection. Okay? Then remember, they say in terms of temperature T. So T has to be here. Okay? In other words, what is the fluctuation of the temperature? Between what and what? Alright. Do all temperatures reach 50 degrees?
Nope.
What about 45?
No.
What about 40?
Yes.
Yes. So all temperatures reach 40 degrees. So this is 40 right here. Ah, of course. So the temperature is between 0 and 40. Ah, you see? This is where this becomes handy. Now the question to you is this. Is 0 included in the temperatures?
Yes.
So I must put an or equal to. Was 40 included in the temperatures? Do all temperatures reach 40?
Yes.
So then I put an or equal to. And therefore this becomes my inequality. So the intersection of the temperatures as an inequality. Good? Excellent. This is the only problem I've seen that pertains to this matter. The other ones, I haven't seen any other problem, so I wouldn't be so sure that I'm going to get something like this on the regents. Alright, so here we go. This becomes tough right now. Problem 48. We're talking about histograms. Now, what is a histogram? Well, a histogram is a graph, a bar graph, okay, where the bars are joined, okay, they are together, okay, see, there is no gap between the bars. This is what we call a histogram, and it's not with Y, okay, it is with I. That is what a histogram is. And how do I construct a histogram? Based on a table. Okay, I refer myself to a table to construct a histogram. Alright, now, what else? Oh yeah, we need to know what a tally is. Okay? Tally is nothing more than a record keeper. Like for example, oh look, somebody tripped right there. Okay, oh, another one right there. Oh, 3. Another one. Oh, 5. See, every 5 is a diagonal. Every 5th tally is a diagonal tally. Okay then. So knowing this, we can go right ahead to our table and start working on the problem. Alright. So you copy this, you pause it, and now remember, in a bar graph, the bars are separate. In a histogram, the bars go together. Now, let us look at this problem. Hopefully you'll be able to see it. It says, Ms. Hopkins recorded her students' final scores in the frequency table below. Alright, this is already completed for us. You see the tallies are right here and the frequency is right here. They want the following. On the grid below, construct a frequency histogram based on the table. Alright, so I'm going to construct a frequency histogram. Good. Let's see if I can make this a little smaller. Not that small. Like that. As long as I can see the whole thing. Alright, so now I can start graphing. Right now I'm going to concentrate on the table and on the histogram. So let's see. The first thing you do is you label your histogram. Alright? The frequency always goes on the y-axis. Okay? And your intervals go right here on the x-axis. Okay? So this is your intervals. Alright. Now, this is how you label your histograms. I mean, your intervals. Take the graph. Look at the table. Do you see what the first interval is? 61 to 70. So, this does not start at 0. Since it doesn't start at 0, I must not go down to the graph. I must not start right here. Okay? I cannot. So what I have to do is I have to create something called a break. This zigzag figure is a break. It denotes, it tells the reader, yo, I ain't starting from 0. I'm starting from 61 to 70. Right? So, from there on, I put a hash mark here, and this is what I tell you. You could do differently if you want to. You could follow different steps. Me, I always count 3 units after every hash mark. So hash mark here, and then 1, 2, 3, hash mark, 1, 2, 3, hash mark, 1, 2, 3, hash mark, 1, 2, 3, hash mark. Why do I do that? That is to allow me enough space to write down the intervals. The intervals are going to be written between hash marks. So watch this. The first interval is 61 to 70. So I'm going to put 61 to 70. Hopefully it fits. Okay? The second interval is going to be 71 to 80. So I'm going to put 71 to 80. Okay. The other one is going to be 81 to 90. And the last one is going to be 91 to 100. Alright, I did it. I'm awesome. I'm cool. Alright. So now I'm ready to start graphing. So let's take a look at the frequency. The frequency here is 5. Oh wait, I haven't labeled the frequency here. So let's do that. Sir, what is the highest frequency here?
9.
9. So all I need is to write the numbers 1 through 9 and I'm done. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. I suggest you write the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, my numbers are not as pretty as yours, but hey, they will suffice the purpose. So let's see now. 61 to 70, I have 5. 61 to 70, I have 5. 71 to 80, I have
4.
4. So, since the bars are together, if this is 5, I go down 1. Okay? The next one, 81 to 90 is 9. Oh my God.
5, 6, 7, 8,
9, and then 3 units. Cool, right? And then 91 to 100 is
6.
6. So I go to 6. And I do this. Now, of course, you know, you want to make it look pretty. I mean, mine's already pretty. Yeah, you feel like do that, you do this, right, you do this, do this. You know, that's like you're not gonna get any more points than what is already stipulated on the test. But it will give, you know, the reader a pleasant view, and maybe they might throw some extra points somewhere. I'm not sure. Okay. So this is your histogram already graphed. Notice that the bars are together, which is a big difference. If you do not put the bars together, as some of you are already doing, because you guys make mistakes, okay? But now, by looking at the video, you see that the bars have to go together. All right? So this is a perfect example. All right then. So let's see what's our next problem. Okay, so this is going to be the last problem we do on this episode of how do we pass the algebra regions. So let's see, 49. The Fahrenheit temperature readings on 30 April mornings in Stormville, New York are shown below. Using the data, complete the frequency table. Alright, let's see. 40 to 44. Let's see. 1, 2, 40 to 44, 3, 4, that's it, 4. So you got the tallies and now you put 4 on your frequency. Alright, now 45 to 49, well, 1, 2, 3, 4, oh wait, 1, 2, 3, 4, okay. I don't want to lose the count. Okay. 45 to 49. Okay, another one. Good. So how many? 1, 2, 3, 4, 5. Okay. 5. Now, 50 to 54. Well, 1, 2, 3, and let me just keep the tallies. 3, 4. That's it. It's 4. Okay. So now 55 to 59. Okay. 1, 2, 3, 4, 5, 6, 7, 'Did I make a mistake?
8.
7,
58.
8, okay, 8, all right. Oh, 8, right? I'm still not sure, I think it's a 7. That's it. 60 to 64. 1, 2, 3, 1, 2, 3, okay, 60 to 64. Then another one here, another one here, another one here, another one here, okay, so that's 7, right? Let's see now. 4 plus 4 is 8, 8 plus 8 is 16, 16 plus 5 is 21. 21 plus 7 is 28. But let's see now, 65 to 69.
2.
1, 2. So that we had 28 plus 2 is 30. Okay, so actually it checks, so we didn't make a mistake. Woo! That's a long problem. That's why it's 4 points on the regions. Alright then. So to start graphing, we know that this is going to be labeled frequency, right? So make sure you label this frequency. Now this in your handout is still over here. But in low font, call it frequency, okay? And these, of course, you're going to call the intervals. Alright. And there's always have to be a title here. The title here would be the Fahrenheit temperature readings. And you just put a title in there. Alright. So the first thing I gotta see is if my table starts at 0. Does it start at 0?
Nope.
No. So therefore there must be like a little break right here. Good. And after that little break, I told you do hash marks, like keeping 3 units of distance. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. 1, 2, 3, okay. And then in the middle we put the intervals in between. So 40 to 44, I'm not going to have enough space here because I cannot write, the ink is not that thin, so, but I'm going to try. 40 to 44, and I'm going to write it going down. 45 to 49, 50 to 54, okay, 55 to 59, 60 to 64, okay. You, on the other hand, you write small and you put the whole interval in there, okay? It's better like that. And the other one is 65 to 69. Okay. And now the frequency. What is my highest frequency?
8.
8. Okay, so 1. Actually, you know what? I can go by 2s, right? So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, okay. So 1, 2, 3, 4, 5, 6, 7, 8. Alright? Now I'm ready to start drawing my graphs, my bars. 40 to 44, we have 4, right? So I'm going to go to 4. Good. 45 to 49, we have 5. If this is 4, then this is 5. 50 to 54. We have how many?
4.
4. Well, if this is 5, I just go down back to 4. Okay. 55 to 59. How many do we have?
8.
Wow. This is 4, 5, 6, 7, 8. 1, 2, 3 units. And then I go down like that. Okay. Now, 60 to 64 is
7.
7. So from 8, I'm going to go down to 7. And last but not least, 65 to 69.
2.
2? Okay, so it's 1, 2. Like that. And of course, you could just,
Make it look nice.
make it look nice. Make it look OD nice. Alright? Alright, did I answer the question? On the grid below, construct and label a frequency histogram? Yes, I did. Did I explain to you the skills that you got right now? If the table does not start at 0, you must do a break. If you don't do a break, even if the bars are correct, everything gets marked wrong. So just be very watchful of that, okay? Another thing I wanted to discuss briefly is from 40 to 44. How many numbers do we have? Do we have 4 numbers or do we have 5 numbers? Think about it. 40 to 44. 40, 41, 42, 43, 44. There's 5 numbers. Why am I saying this to you right now? Because on the next group of problems, we're going to have to be faced with this challenge of knowing how many numbers in between. So there are 5 numbers here. From 45 to 49, still 5 numbers. From 50 to 54, still 5 numbers. Look at this. You don't repeat 49 here. You go from 49 and you go to the next number, which is 50. Why? Well, because then there will be an overlapping of numbers being tallied. That's why. So we move on, but all the intervals must have the same range, the same amount of numbers from one to the other. 5, 5, 5, 5, 5, 5. Just remember that, okay? Alright, so until next episode of how do we pass our regents? Alright, good. Okay, welcome to another episode of How Do I Pass My Algebra Regents? Alright, problem number 50. Let's see. The test scores for 18 students in this class are shown here. Complete the frequency table below. Alright, I'll do it. From 51 to 60. 51 to 60. Let's see. 51 to 60. 51, okay, 58, that's one. 52, that's another one. That's it, right? Okay. Now the next one. 61 to 70. 61 to 70. 64, okay, 61 to 70. 61 to 70. That's it, right? Okay. The next one. 71 to 80. 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 Okay, so I have 1, 2, 3, 4. Okay. 1, 2, 3, 4. You don't do it like the way I just did it. As soon as you cross out one, you put a tally. Me, because they are color coded, okay? Now 81 to 90. 81 to 90, so 81 to 90. 81 to 90. 81 to 90. 81 to 90. That's it. Okay. So 5. And now 91 to 100. Well, I used up all the colors, so let me use black again. 91 to 100. 1, 2, 3, 4. 1, 2, 3, 4. Okay, cool. So now the next step in completing the table is the following. How many do I have here? 2, 2, 4, 5, and 4. Now always check that the number you have here matches with this number right here. 18, let's see. 2 plus 2 is 4, plus 4 is 8. Okay? Whoa, you see, it's not matching. 2 plus 2 is 4, plus 4 is 8, plus 9 is 17. So where did I go? Ah, of course. Watch this. 81 to 90. There's another one right here. So this number becomes 6. And now I have 18. Oh my God, thank God I checked. I did not do this on purpose. Alright then, so now I'm ready to draw and label my frequency histogram right here. So let's do it. The first thing you do is check if the table starts at 0. It doesn't, so we do our little break right here. Okay? And then you follow my advice, or you could actually, it's up to your own criteria, how many spaces you want to leave between hash marks. Me, I already said it. I'm going to leave just 3 units. So my first hash mark is here. Then 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay? Unfortunately, I should have left 4 in here, a gap of 4, because I don't know if I'm going to have enough space to put the intervals. Remember, you must label these intervals. Alright? So now let's see if they fit. Alright, the first interval is 51 to 60. So what I'm going to do, I'm going to write it like this. 51 to 60. Now you, on the other hand, it should be horizontally like this. 51 to 60. Alright, the next one is going to be 61 through 70. Okay. 61 through 70. The next one is going to be 71 to 80. You get the drill, right? Please try to work faster than I am. So by the time I'm done with this, you already have the answer, and I don't have to ask you, okay, this and that, and explain to you. This is 81 to 90, okay? And this is 91 to 100. Okay. Am I ready to graph, to draw my histogram? Of course I am ready. I'm always ready. I'm beker. Okay. So, 51 to 60. How many we have? 2. So, oh, wait. I almost forgot. You must label this right here, okay, in small with your pencil. You label it frequency. Okay? You label it frequency. I'm not going to do it here because I don't have enough space. And not only that, the next thing I do before graphing the lines is check what is the highest frequency. It's 6. Alright, so I'm going to start here. This is 0. And you know what? I'm going to go by 2s. Every 2 units I'm going to put one number. So 1, 2, 3, 4, 5, 6. Okay? You put the numbers 1, 2, 3, 4, 5, 6. I don't have enough space. So now let's draw our histogram. 51 to 60. 2. OD. 61 to 70. 2. 71 to 80, 4. 81 to 90, 6. Oh, D, I'm awesome. And what else? 91 to 100 is 4. So 91 to 100 is 4, so 4 right here. And I got it. I got my histogram. And I got my 4 points. Awesome, right? Yeah, I know, it's beautiful. Alright, so now let's do our next problem. Hopefully you have enough time to copy if you haven't already done so, because I know you're very smart. Okay, problem number 51. Alright, I'm going to make this a little smaller because it's a big question. But you have the packet right there. And you could zoom in if you want to. Alright. So, the first question, okay, it says, I'm going to make it larger. Alright. Right here. 20 students were surveyed about the number of days they play outside in 1 week. Alright. The results of the survey are shown right here. Complete the frequency table below of this data. Alright, so let's do this. You should be working with me right now. Let's start. From 0 to 1. Well, let's see. 1, 2, 3. Alright, cool. Now, from 2 to 3. From 2, okay, so 1, 2, 3, 4, 5, 6, okay, 7, wow, that's it, okay, and now from 4 to 5, 4 to 5, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, okay, and from 6 to 7, 1, 2, 3. Okay, 1, 2, 3. The next step is to complete the frequency. Frequency is the number of tallies. So let's see. Here I have 3, I have 7, I have 7, and I have 3. Alright. This is the easiest thing to do. Now let's go on to the second part of the question. Okay, let me make this a little smaller now. Okay, it says complete the cumulative frequency table below using this data. Well, the cumulative frequency is nothing more than the sum of the frequencies. Please try to understand this. This is very complicated. So, from 0 to 1, notice that the intervals start at the same, right? That's only the first interval, okay? They start the same numbers. So from 0 to 1, I have 3. Excellent. Now watch this. This table is asking me from 0 to 3. From 0 all the way to 3. From 0, that starts here, all the way to the 3 right here. So, wait, hold on, it's asking me for these 2 little boxes right here. That's why it's called cumulative frequency. So 3 plus 7 is 10. Got that? And guess what? If I wanted to go backwards, I say, wait, hold on a second. I added something to 3 to get to 10. Or I added 7. So if I want to go back, I subtract 7. How do you go from 10 to 3? You subtract 7. Okay, just in case you want to reverse engineer the problem. Alright, so now from 0 to 5. From 0 all the way to 5. How many we have? Well, this covers 1, 2, 3 rows. So let's see, 3, 10, 17. Oh. Now, from 0 to 7, that's the whole enchilada right here, look. That covers all the intervals from 0 to 7. So that's the whole thing. 3, 7, that's 10, right? Plus 7 is 17, plus 3 is... You got it? Alright. So now, I have my cumulative frequency table. And right now, we get ready to cover another skill. The skill is how you go from the cumulative to the regular. This is called the regular frequency table. This is called the cumulative frequency table because you add all the intervals, all the frequencies. You see that? Alright then. So if you want to go back from here to here, this is what you say. From 20, how do I go to 17? I subtract 3. There you go. Okay? From 17, how do I go to 10? I subtract 7. From 10, how do I get to 3? I subtract 7. And backwards, from 3 to 7, add 7. From 3 to 10, add 7. From 10 to 17, add 7. From 17 to 20, add 3. And that's how you get this table. Alright? What else? In a cumulative, and maybe you should write this down. In a cumulative frequency table, all intervals start at the same number. Oh, yes. The same number. As for the regular frequency table, no, they don't. See, 0 to 1. And not only that, understand that they cannot overlap. This interval cannot start at 1. It cannot be 0 to 1 and 1 to 2 and 2 to 3. No, it's 0 to 1 and then the next one. How many numbers from 0 to 1? 2 numbers. 0, 1. So then the next one will be 2, 3, 3, 4. It's always the same amount of numbers between the first and the last. Alright, enough of that. I don't want to keep up take your time. So let's see what it says. On the grid below, create a cumulative frequency histogram based on the table you made. This is the table you made. So now we're going to create a cumulative frequency histogram. Alright, I can do this. First of all, let's see if I can make this a little larger. So what I'm going to do is the following. Zero to 1, 0 to 3, 0 to 5, and 0 to 7. And the numbers were 3, 10, 17, 20. Okay, why am I doing that? Because maybe I can make this a little larger and don't need that table. Good, I think I did. Why? Because I'm awesome. Yeah, that works. Alright, so let's create our cumulative frequency table. The first question is this. Does it start at 0? Yes! What happens? I don't have to do this. I don't have to do the little break. Good day. So I start here. So I start my first hash mark. Then in this case, I'm actually going to go by 4 units. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, you could go by 5, by 3 units. I already told you, I go by 3 units because that's the best for me. Alright, the first interval is 0 to 1. 0 to 3, 0 to 5, 0 to 7. Okay, it's cumulative, so they all start at the same number. Alright then, now the frequency. What is the highest frequency? The highest frequency is 20. So I'm going to have to go by ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh my God, so everything's... Alright, so this is 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is 10. 11, 12, 13, 14, 15, 16, 17, that's 17, 18, 19, 20, okay, this is 20. All right. So now I'm ready to create my histogram. So let's see. 0 to 1, I got 3. So 0 to 1, I start at 3. Awesome. Then 0 to 3, I got 10. Hey, 0 to 5 is 17. 0 to 5 is 17. Hey! And of course, 0 to 7 is 20. 0 to 7 is 20. Oh man! Ah, now I know. Alright, so this is my cumulative frequency histogram. What is the difference between this histogram and the regular frequency histogram? Well, you see the bars? They fluctuate, they change height. Could be lower or higher, as opposed to the cumulative frequency histogram, that each bar is higher than the other. But it makes sense because you were adding the frequencies, okay? 3 plus 7, 10. 10 plus 7, 17. 17 plus 3 is 20. That's how you get it. And guess what? Please, it is your responsibility to try to understand how to go from a histogram to the cumulative to the regular. Or in other words, how to go from the graph and create a table. Alright, on the following session, we are going to discuss how to go backwards, how to reverse engineer a histogram, okay? Alright, these problems take a long time, so just, relax. Alright, see you on the next episode of How Do I Pass My Algebra Regents? Alright, welcome to another episode of How Do I Pass My Regents? Oh yeah, and some of the teachers said to say, welcome to Beker's world. Anyway, so let's do problem 52. The table below shows a cumulative frequency distribution of runners' ages. So you have a cumulative frequency. Remember what I said in the previous episode, that when you see cumulative frequency, all the intervals start at the same number. Well, in this case, they all start at 20. So yes, it is a cumulative frequency. Perfect. All right. The question says, according to the table, how many runners are in their 40s? And the first thing that you're going to answer is 25. 25, that's the answer. And I'm going to say it with sorrow in my heart that that is not the answer. You think this is the answer because you see the 40. That doesn't matter. You have to use your reasoning. Say, remember what I told you in the previous episode. You need to deconstruct the cumulative frequency and reverse engineer to a regular frequency. So that's exactly what we're going to do. I am going to create another table, okay? And now, let me see, 1, 2, 3, 4, 5, something like that. Anyway, so the frequencies, the intervals here are, the first one, 20 to 29. Now I'm going to tell you something. Whether it is a cumulative frequency or it is a regular frequency, the first interval is always the same. And the first frequency is always the same. Okay, perfect. Now, I don't know if you remember in the other episode when I was telling you, okay, how many numbers from this to that? Well, how many numbers from 20 to 29? How many numbers?
9.
Okay, you might say 9, but unfortunately that is wrong. If we count, we know this, because you gotta start counting from the 20. So you have 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So now that you have a better understanding, how many numbers do you think I have?
10.
10 numbers. There are 10 numbers from 20 to 29. Usually, from 1 through 10, you have 10 numbers. But from 0 to 10, that will be 11. So try to compare those. So there are 10 numbers. Why is this important? This is important because that tells you the range of the intervals. So guess what? If the first one was 20 to 29, then remember that you never repeat the number. So this is going to be 30. We know the range is 10 numbers, so it's going to be 30 to 39. 40 to 49. 50 to 59. And 60 to 69. Okay, perfect. Now, to do the other part, the frequencies, okay? These are the frequencies. So as I said before, the first frequency is always the same. All right. Now, remember that this is just the sum of all frequencies. So we could work backwards to figure out what the other frequencies are. For example, from 20 to 29, you have 8. Perfect. From 20 to 39, in other words, from 20 to 39, you have 18. So between these two columns, you have to have 18. That should make this a 10. Because this, from 20 to 39, from 20 to 39 is 18. So from 20 to 39 should be 18. 10 plus 8, 8 plus 10 is 18. Perfect. So then, guess what? The next, from 20 to 49 is 25. From 20 to 49 is 25. You have 18. So how do you go from 18 to 25?
7.
Excellent. We add 7. Now let's see if you got the hang of this. From 25 to 31, how many numbers do I have to add to get to 31? 6. And then from 31 to 35, I have to add 4 numbers. Excellent. So now I am ready to answer the question. How many runners are in their 40s? Let's go back to when you said 25. 25 doesn't cover the runners that are in their 40s. 25 covers the runners that are in their 20s, in their 30s, and in their 40s. That's why we have to deconstruct this table and reverse engineer it to the original table. So, how many numbers, according to your reasoning, are in their 40s?
7.
7 runners. So the correct response is choice number 3. 7 runners. See? It's simple once you get familiar with the reasoning and the concept. Alright, let's go on to the next problem. Problem number 53. Alright, so let's see. Do we have a visual on 53? Excellent. So, the cumulative frequency table below shows the length of time that 30 students spent text messaging on a weekend. That really is irrelevant. The only important number here is 30. Alright. So you have the intervals and you have the frequencies. Remember what I said about a cumulative frequency table. All intervals start at the same number. Cool. So now, the question. Which 10-minute interval contains the first quartile? Do they look like 10-minute intervals here to you? The first one might be a 10 because from 31 to 40 you have 10 numbers. So these could be 10 minutes. But from 31 to 50 is not 10 minutes, it's 20 minutes. I know what I gotta do. I gotta deconstruct and reverse engineer this table from cumulative to regular frequency. So that's exactly what I'm going to do. I create my table. As beautiful as the other one. Jeez. Okay. So now let's see what I can do. It takes time, but it's worth it. So the first interval is 31 to 40. The first interval, as I said before, is always the same. The second interval, well, remember, I don't even have to count the numbers because they already tell me that they are 10-minute intervals. So I know it's 10. And we know that we can never repeat the ending number right here, 40. We gotta move on to the next one. So the next one is gonna be 41 to 50. The next one, 51 to 60. 61 to 70. 71 to 80. Okay, perfect. I deconstructed the intervals. Now, I need to work with the frequency, okay? This is like doing some Chuck Norris stuff. So, 31 to 40, the frequency is always the same. Now, from 31 to 50, from 31 to 50, that's two rows right here, okay? From 31 to 50, I have 5. So, I'm supposed to have 5 between these two rows. So, 2 and then plus what is 5? 3. 2 plus 3 is 5. So from 31 to 50, I got 5. Okay, from 31 to 60, I go from 5 to 10. So I gotta go from 5 to 10. What could be this frequency right here? I need to go from 5 to 10.
5.
I add 5 more. Excellent. That makes it 10. Now from 10 I went to 19. Oh my God. From 10 I go to 19. From 31 to 70. From 31 to 70 I go to 19. How much more do I need to add? From 10 to 19, how many do I add? 9. Excellent. And now from 19 to 30, ooh, I need the calculator for this one. 19 to 30, how much do I need to add? I can't hear you. 11, okay. Awesome. Now, now we can answer the question. Which 10-minute interval contains the first quartile? Quartile means 25%. Well, let's see, we have 30 students. So, if we divide 30 students, okay, half of the students is 15. And half of 15 is 7.5. In which of these do I get 7.5? Let's see. 2 plus 3 is 5. This is not 25%, right? So it has to be on the interval of 51 to 60. That's where 7.5 lies. Get it? Right now, we don't know anything about quartiles. Okay, so this is the easiest way of calculating this. When we start looking at box and whisker plots, I'm going to explain to you how to get quartile 1, quartile 2, and quartile 3. Alright, so this is the answer, right? What was it again? 51 to 60? So we got 51 to 60. Let's answer the next question. Number 54. Alright, this is one of the toughest questions that you're going to find on the Regents. And of course, it's worth 4 points. Let's see. The diagram below shows the cumulative frequency histogram, okay? In the previous episode, in the last episode, I explained to you what the difference was between a cumulative frequency histogram and a regular frequency histogram. I'm going to do a sketch right now of a regular frequency histogram. This is a regular frequency histogram. It's not New York City. And this is a cumulative frequency histogram. See, the bars going up. It's just like the table. Let me show you. Look at this table. The cumulative frequency table always goes up. The regular frequency table, well, in this case it went up, but in reality it could have so many different values going up and down. So that's why we have a regular frequency histogram. The bars will go up and down. On a cumulative frequency histogram, the bars going and increasing order, whatever you want to call it. Alright, so let's say this. 54. Do we have a visual on this? Okay. Determine the total number of students in the class. Determine how many students score higher than 70. State which 10-point interval contains the median. State which two 10-point intervals contain the... Oh my God, I'm gonna go crazy. So the first thing is to reverse engineer this histogram. That's exactly what I'm gonna do. So the first thing I'm gonna do is I'm gonna create a table. Now let's see. What is the first interval? 41 to 50. Then the second one is 41 to 60. Then the third one is
41 to 70.
41 to 70,
41 to 80.
41 to 80.
41 90.
41 to 90. Oh my God, I still have another one? Jesus Christ. What is that, 41?
It's 100.
Alright. So this is the interval part. Now let's do the frequency part. Okay, from 41 to 50, how many do I have? 2, right? From 41 to 60, I got 5. From 41 to 70,
10.
okay, 10. From 41 to 80,
18.
18. From 41 to 90,
24.
and from 41 to 100,
30.
30. Alright, excellent. This is still not going to help me solve the problem. This is the cumulative frequency table. This is your cumulative frequency table. I need a regular frequency table. Okay? So let's see if I can do this. Let me see. Okay. Maybe I could create it right here. Let's see if I can do this. I'm going to make the problem smaller and I'm going to write, okay, and I'm going to write down here the other table. We already have this table. We already read the information from here. Now I am going to create another table. Okay. Now what is this table going to be? Well, this table is going to tell me, sorry. Okay, this table is going to tell me the regular frequency. So let's see. The first interval, as I said before, is the same as the cumulative frequency. Okay, now, remember how many numbers. You have to know what the distance from the first to the last is in order for you to come up with the other intervals. So 41 to 50, we have 10 numbers of difference. So the next one, and since you cannot write the 50 here, you know that the next one is going to be 51 to 60. The other one is going to be 61 to 70. The other one is going to be 71 to 80. The other one is going to be 81 to 90. The other one is going to be 91 to 100. And the last, no, that's it. This is the last one, right?
Yes.
Oh my God, thank God. All right. And now for the scores. Okay. So, let's see. From 41 to 50. Oh, I don't have it? Okay, let me. From 41 to 50, I got 2. So that's exactly what I'm going to write over here. 2. Now, from 41 to 60, I got 5. Therefore, from 51 to 60, how many do you think I have? Guys?
7.
From 41 to 50, I got 2. From 41 to 60, I got 5. From 41 to 60, I'm supposed to have 5. From here to here, I'm supposed to have 5. I already got 2. So what do I need?
3.
Okay. Now, from 41 to 70, I got 10. From 41 to 70, I'm supposed to have 10.
5.
So I'm going to add 5. Then 18. So I'm going to add 8.
You need 9 because you know 61.
Say it again.
61 minus 70 is 9.
61 minus 70. Sir, these are intervals. These are fixed numbers. I'm looking at the frequency here. From 2 to 5, I added 3. From 5 to 10, I added 5. From 10 to 18, I added 8. From 18 to 24, I'm going to have to add 6. From 24 to 30, I add 6. Make sense? Alright. So now, let us answer each of the questions. So let's see, I'm going to make this a little larger. So the first question is, determine the total number of students in the class. How many students in the class? Well, you get that from here, the tallest bar. Or you get that from the cumulative frequency table. There are 30 students in the class. So, okay, the question to the first one is 30 students. Okay? We see this? Excellent. Now, taking care of that question. Determine how many students scored higher than 70. This table is not going to tell me how many students score higher than 70.
The second one.
Unless you use your reasoning, your common sense, and you say, from here to 70 there are 10. So I guess after 70 we got 20. But if not, then we're going to use the regular frequency table that we created. Okay? From 61 to 70. That means that this is higher than 70. Anything from here to here is higher than 70. So how many? 8 plus 6 is 14. 14 plus 6 is 20. So 20 students score higher than 70. So, okay, 20 students, okay, 20 students scored higher than 70. Alright? This is not the appropriate way to write it on the regions. You actually write 20 students scored higher than 70. Alright, now to answer one more question. State which 10-point interval contains the median. The median. What do I know about median? I haven't spoken about median, but my common sense tells me that the median is the middle number. Does it make sense to everybody? Of course it does, right? So, the middle. How many students do we have in total?
30.
30 students. So, half of that, the median, the middle, should be 15, right? Okay then. So, we could use either table, right? But since they're talking about 10-point intervals, let's use our 10-point intervals. Alright, so half of 30 is 15. Tell me when I reach 15, okay? 2 plus 3 is 5, okay. 5 plus 5 is 10, not 15. 10 plus 8 is 18. Ah, so right here I reach and pass 15. So these two 10-point interval contains the median, 71 to 80. So you write 71 to 80 is the 10-point interval that contains the median. Alright? Good. Now, what is the last question? State which two 10-point intervals contain the same frequency. Ah, this is the beauty. These are the benefits of reverse engineering the table. We went from this graph to the cumulative frequency table, and from the cumulative frequency table to a regular frequency table. Now, to you, which two 10-point intervals contains the same frequency? 81 to 90 and 91 to 100 contain the same frequency. So you write on the regions or on your paper, 81 to 90 and 91 to 100 contain the same frequency. You don't just circle this, because that is telling nothing to the reader who's going to grade your paper. Okay? Your papers go out somewhere in the city and they get graded by other teachers. Make sure you give a thorough explanation of what the answer is. Okay? Alright. So let's see now. I hope, okay, we could pause this and then you could copy the intervals, because I gotta erase this table right here. Hey. Alright, so now I'm gonna erase it. Like nothing happened. Cool. Okie dokie. Question what? 55. Okay. Wow. Well, let's see what it says. The following cumulative frequency histogram shows the distances swimmers completed in a recent swim test. Okay. Is this a cumulative frequency histogram? Yes. Why? Because I see it that the bars are in an increasing order and it says cumulative frequency histogram. It says, based on the cumulative frequency histogram, determine the number of swimmers who swam between 200 and 249 yards. Determine the number of swimmers who swam between 150 and 199 yards. Determine the number of swimmers who took the swim test. Oh my God. Alright, so once again, they gave me a cumulative frequency histogram. That means that I have to deconstruct this problem and reverse engineer in order for me to answer all these questions. Alright then, so that's exactly what I'm going to do. I'm not going to be lazy. Now, I could answer the first question though. Determine the number of swimmers. Well, the last bar in a cumulative frequency histogram tells you the total number of whatever you have. Okay? So, I can say that there are 20 swimmers. Okay. What else? It says, let me make it smaller. Alright, better? Yes. Okay, it says, determine the number of swimmers who swam between 200 and 249. Between 200 and 249. I can tell you right now what it is. Okay? It's not really this one. It's actually just this many numbers. But you know what? Practice makes perfect. You need to practice on how to visualize the problem in order to answer it. But right now, I'm going to work with you and we're going to do it the long way. First, I'm going to construct a table. Okay, so we have the intervals. 50 to what? To 99. We have 50 to 149.
50 to 199.
50 to 199.
50 to 249.
50 to 249.
50 to 299.
50 to 299. Okay. So now, let us do the frequency. What do I get as a frequency? Okay, from 50 to 99 you have how many? 7. From 50 to 149 we have
12.
12.
12.
50 to 199.
12.
12. From 50 to 249. 15.
And 20.
From 50 to 299 we have 20. Alright then. Now we're going to construct the other table. So let's see how we do it. Okay, so my intervals, what type of intervals are these? From 50 to 99, how many numbers do we have?
49.
59, 50 numbers. Yes, remember that you're counting. Remember, from 1 through 10 is 10 numbers. From 0 to 9 is still 10 numbers. From 0 to 9 is 10 numbers. So that means that from, if you were saying from 51 to 100, that would be 50 numbers. Now you're saying from 50 to 99, it's the same thing, still 50 numbers. So let's see, my first interval is 50 to 99. Well, guess what? I said before, the first interval always remains the same. Okay, now it's 50-point interval. So from 99, what's the next number? 100 to 149. From 149, what's the next number?
150.
To 199.
99.
The next one would be what?
200.
200.
249.
And then from 250.
250. 299.
Excellent. Okay, now let's figure out the frequency. The first frequency is always the same. From 50 to 99, we have 7. Excellent. Now from 7, I went to what? To 12. How much did I add to get to 12? 5. From 12, I stood at 12.
0.
So I added 0. From 12, I went to 15. So I added 3. From 15, I went to 20. So I added 5. Okay, now that's it. It's over. Look, I got the histogram, I got the cumulative frequency table, and I got the regular frequency table. Now I can answer any question they throw at me. Okay, the first one was, how many students? Well, we know we got 20. The second one was, the number of swimmers who swam between 200 and 249. Between 200 and 249?
3.
Exactly. 3. So, your answer is 3 swimmers swam from between 200 and 249. Alright? That's what you write. The next question was, determine the number of swimmers who swam between 150 and 199. How many?
5. Oh wait, no, 0.
0. None. Nada. No swimmers. Alright. Determine the number of swimmers who took the swim test. Oh, that's why. It's 20. 20 swimmers took the swim test. I was wrong about reading this question. I thought it was they were asking, the first question was determine the number of swimmers. No. Determine the number of swimmers who swam between 200 and 249. Oh, well, we did answer right here. 3.
We already answered that.
Then the next one, between 150 and 199.
0.
0. And then determine the number of swimmers who took the
20.
test. 20. Alright, awesome. Alright, let's do the next problem now. Ah, beautiful. You're about to acquire a new skill. New skill for this question 56. So, let us refrain from this question right now and let us just write a little bit of in our notebook. So let's see now. Okay. First of all, These figures right here are called box and whiskers. Okay, so what we're going to do right now, we're going to figure it out. So this is called a box and whisker plot. Box and, I don't know how to spell whisker, so I'm assuming it's like this. Box and whisker plot. Do we see this? Alright. The parts of a box and whisker plot are the following. Minimum, quartile number 1, quartile number 2, quartile number 3,
Maximum.
and maximum. Alright, but how do I get to all those? Easy. When they talk about box and whisker plot, they all just talking about medians. And what do I know about medians? That they are the middle number or the middle element in a set. You know what a set is already. So for example, and I'm going to write that in color. If I have the numbers 1, 2, and 3, the median is 2. If you have the numbers 1, 2, and 3, a different method would be cross out the extremes until you get to the middle. Let's say you have the number 9 here, no, the number 0, and the number 4 here, right? Then you cross out extremes, cross out extremes, cross out the extremes, and you end up with your middle number. Yes, but what happens when you have an even amount of numbers? Like this. Then guess what? You cross out, you cross out, you cross out, you cross out, but you got nothing left. Oh, wait. Take the two numbers left in the middle, add them up,
Divide.
and divide them by 2. So your median here becomes 2.5. Okay? That's all you gotta do. So if you cannot find a middle number, like you don't have a concrete number in the middle, you end up with two numbers, add them up and divide by 2, and that is going to be your median. Alright then. So the minimum is the middle number. The maximum is the highest number. Now let's see what Q1, Q2, and Q3 are. This is called the lower quartile. This one right here is called second quartile or the median. That's the first thing you find. Every time you're working with box and whisker plots, that's the first thing you find. This is called the upper quartile. Alright? Now let's pause this, okay? Or give you time to copy so we could actually move ahead with the problem. I'm in pause. Okay, enough time to copy this. Let us erase the topic. And now, let us go here and let us see what's up. They want to know which box and whisker plot represents the data. Which of these box and whisker plots represents this data? Well, let's construct a box and whisker plot so we get first hands on how to do it. I said that the parts are minimum, quartile 1, quartile 2, quartile 3, and maximum. And the first thing that you find is the quartiles. In order for you to find the median, the numbers must be in order, in ascending order, okay? Let's see, 5, 6, 7, 8, 9, 9, 9, 10, 12. Okay, good. They are all going in an increasing order. So this is fine. Now let's find the median. How many numbers do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15, 16, 17 numbers. That means that I can have 1, 2, 3, 4, 5, 6, 7, 8. Okay? 8 numbers this way. I can have 1, 2, 3, 4, 5, 6. Wait.
You counted wrong.
I counted wrong. Definitely I counted wrong. 17 numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, 15 numbers. I'm sorry. So that means 15. That means that I can have 1, 2, 3, 4, 5, 6, 7. 7 numbers this way. And 1, 2, 3, 4, 5, 6, 7 numbers this way. Good. So now I know that my median is 10. So 10 becomes my quartile number 2. Cool. Now guess what happens when you find the first quartile or the median? Well, your data gets divided into 2 sets from the median. This actually goes all the way here, okay? See? Okay, like 18, 19, 19 goes this way. Alright then. So what is it that you're going to do now? Easy. It's all about medians. Now you're going to find the median here. Well, I can tell you right now. What do you think the median of this set is? 8. See, 3 numbers here, 3 numbers here. 8 is the median. So I just found quartile number 1. See that? Over there, the lower quartile. 8. Now let me find quartile number 3.
17.
What do you think is the median between these sets right here?
17.
17 is the median. You see 3 numbers here and 3 numbers here. Okay, so 17. Now let me construct my, oh, wait. I need my minimum, which is what?
5.
5. And I need my maximum,
19.
which is 19. Perfect. I got all the information I need to create a box and whisker plot. So let's see. This is the median, so that's where you start. Okay? The median is going to be 10. Now I want to go that way. This is going to be my first quartile, which is 8. Now, this is going to be my third quartile, which is going to be 17. And now the whiskers are the minimum
5.
and the maximum 19. Alright, I have just learned how to construct a box and whisker plot. So now let me figure out which of these box and whisker plots could be the answer to my question. Okay, first of all, when you are given a multiple choice based on box and whisker plots, the first thing you look at is the median. This right here, that's the first thing you look at. If all of them have this, then you go on to something else. Alright? So let's see. Is the median here 10? No, it's 12. Is the median here 10? Okay, so we have a candidate right here. Is the median here 10? Is the median here 10? So then you know what? Look no more. Your answer is number 2. Alright, we're going to be looking in more detail. Okay, we're going to get into box and whisker plots on our next episode of How Do We Pass, or How Do I Pass My Algebra Regions. Thank you. Alrighty, welcome to another episode of How Do I Pass the Algebra Regions. So we are going to do problem 57. Alright, so the test scores from Mrs. Gray's math class are shown below. So we got these numbers right here. Now, they are asking us to construct a box and whisker plot to display this data. Box and whisker plot. Oh, they want me to do something like this. Like a box, that, and with the whiskers, right? Alright, cool then. So that's exactly what I'm going to do. Now, Remember the parts of a box and whisker plot. We have quartile, no, sorry, we have the minimum, we have quartile number 1, quartile number 2, quartile number 3, and we have the maximum. Okay, now what is a box and whisker plot? How do I construct that? Easy, it's all about the medians, remember. Now if at some point you see a problem says that's talking about the box and whisker plot, and you read something about the mean or the mode, no, that has nothing to do with the box and whisker plot. It's all about the median. And how do I find the median in a set of numbers? The numbers must be in ascending order, increasing order from smallest to largest, okay? So then let's write these numbers from smallest to largest because I see that they're not. All right, so help me out. What will be the first number?
66.
66? Okay, I'm going to start right here. Is it visible? Okay,
Yeah.
66. What's the next number?
71.
71,
72.
72,
73.
73,
82.
82,
85.
85,
85.
85 again?
Yes, sir.
Okay,
86.
86, wow.
89.
89,
91.
91,
92.
my God, 92,
And 95.
and 95. All right, so these are all the numbers in order from least to greatest. Perfect. So once again, I'm going to say it again. It's all about the medians. So the first thing we do is we find the median of this set of numbers. So let's see. The easiest way to find the middle number is to cross out the extremes. I could do it, but let me show you. I don't know if it's an easier method or a simpler method or mentally. How many numbers do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 numbers. So half of 12, it's 6. So I could have 6 numbers this way and 6 numbers that way. But then again, I will have a median. Let's see. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. Oh, wait. I have 6 numbers there, 6 numbers here, but then I have no median. I have no number in the middle. You know what? Let's cross out the extremes. Let's see, maybe that works. Okay. First with last. Second with the other ones. Third, da, 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 da. Still have no median. So what am I going to do? Easy. The median is hidden between 85 and 85. So what you do is take these numbers, the two numbers in the middle, okay? Take the two numbers in the middle, add them up, and divide by 2. Okay, so I'm going to take 85 and 85, I'm going to add them up and divide by 2. I could do that. So 85 plus 85 is 170. Alright? Look, let me see. Do I have a calculator? Here. Oh, yeah. That I just upgraded. Is the calculator visible right now? Okay, so 85 plus 85 is 170. If I divide that by 2, I still get 85. Oh my God, that's awesome. Alrighty, so I get 85. So my median becomes 85. The median here is 85. Now remember what this is? The minimum is the lowest value. Quartile number 1 is called the lower quartile. That's on this side. Quartile number 2 is the median of medians, the real median, the first median that you find, that is quartile number 2. And I just figure out that the median is 85. Okay. Now, what does this median do to our set of numbers? It divides it into 2 groups. See that? Does this starts to look like the box and whisker plot? Of course it does. Okay then. You see? Yeah, it's still right. Okay. Now what I'm going to do is I'm going to find the median of this set of numbers. Okay. So how many numbers do I have? 1, 2, 3, 4, 5, 6. Oh my God, again. Remember, put 3 numbers here. Okay, sorry about that. Sorry about this too. Okay. So 3 numbers right here and 3 numbers right here. So the median is going to be somewhere between 72 and 73. So guess what? I don't have to add them up and divide by 2 to figure it out because I'm OD nice, I'm smart. What's between 72 and 73? Well, 72.5. Ah, I bet you didn't know that. And now, I need to find the median of this group of data, of this set of numbers. So that's exactly what I'm going to do. How many numbers do I have? 1, 2, 3, 4, 5, 6. So if I cross out, right, like that, like this, oh my God, I end up with 2 numbers. So once again, you add the 2 numbers and you divide by 2. But since I'm OD, visibly nice, I know what's between 89 and 91. 90. So we got 90, so I just found quartile number 3. Now, since you guys helped me out to put the numbers in order, now tell me what is my minimum value? What is the lowest value?
66.
66, very good. Excellent. And what is the maximum value? 95. All right, now it's a course. Excellent. So now I'm ready to construct my box and whisker plot. So for the purposes that you deem necessary, you could pause this and copy the numbers and do all the things that I did. I have to erase these numbers because I need space to construct my box and whisker plot. So let's pause it. We don't pause.
You know they don't see that.
Awesome. So let's see, erase, 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 and voila. Nothing is there. Because I did magic, I erased the whole. Okay, yeah, I'm missing too. Alright, so let's see now, let's construct our box and whisker plot. So my lowest value was 66, alright. But if you follow Beker's way, the first thing you want to trace is the median. The median, which is quartile number 2. Quartile number 2 is the median. 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 Yes, I know you get it. So, it's 85. So this is my median right here. Alright. From this median, I'm going to part ways to my first quartile. My first quartile is 72.5. If this is 70 and this is 75, 72.5 should be around here. Ah, look. Awesome, right? And now let me go to my quartile number 3, which is 90. So 90 is right here. Okay, let me connect this. Starts looking like a box and whisker plot, except with all the whiskers. And now, last but not least, my whiskers are the minimum and the maximum. So minimum is 66. 65, so 66 should be around here. So I'm gonna go, and that's it. I'm gonna stop right there. Okay, do that again, at the car. Excellent. And now, maximum is 95. Right that. See that? Box and whisker plot successfully constructed. Alright then. So this is how you do it. Let's go on to the next problem, okay? Problem number 58. Is that visible?
Yes.
Awesome. So let's see now. The number of songs 15 students have on their MP3s This is an old problem. We don't do MP3s anymore. We do MP4s, and we have iPads, and we have different extensions, and that's not what I'm supposed to be doing right now. I'm supposed to focus on the problem. So let's do this. We got these numbers. It says state the values of the minimum, first quartile, median, third quartile, and maximum. Using these values, construct a box and whisker plot using an appropriate scale on the line below. Now let me explain this to you right now. You see these words right here, this problem right here? 4 points. Okay? See this problem right here? 2 points or 3 points. What's the difference? Nothing. It's just that the wording makes it look more difficult. Why? Because on problem 57, we had to find a minimum. We had to find the quartile number 1, quartile number 2, quartile number 3, the maximum. They didn't tell us to do it. They just asked us to construct a box and whisker plot. But guess what? In order to do this, you need to figure out all the parts of the box and whisker plot. So that's exactly what I'm going to do. Alright, so problem 58. My question to you is the following. Are the numbers in ascending order? Are they increasing? Are they going from lowest to highest?
Yes.
Thank you very much. So yes, they are. So then all I gotta do is find the medians, because that's what a box and whisker plot is all about. Alright. Now I am going to write the numbers here, because if I start doing it the way they are right now, I might confuse you. So we do, okay, so we have 120. What's the next one?
124.
Okay, 124.
132. 145. 200. 200. 255. 260. 292. 308. 314. 342, 407, 435, and 452.
Wow. Let's see now. If we have that. What was after 407? What did we have?
435, I mean 421.
Okay, I'm going to put it right here. 431.
21.
Or 21? Okay. 421.
435.
435.
And 452.
And 452. All right. So hopefully this is better than this layout. Unfortunately, I couldn't put all the numbers on one line, one row. So let's see if it works. All right. So what is the first thing I'm going to find? Well, what are the parts of the box and whisker plot? We have a minimum. We have quartile number 1, quartile number 2, quartile number 3, and we have a maximum. All right. Cool. So let's find, well, the minimum, we already know what it is. What is it?
120.
Okay. Now the maximum is what?
452.
452. I feel you. So, let's find quartile number 2. That is the first quartile you're going to find. Quartile number 2, because that's the median of medians. All right. So with that in mind, let's see. Let's find the median. Let's count how many numbers we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. Oh my God, good day. 15 numbers. That means that since the number of numbers, the amount of numbers is odd, because there are 15 numbers, I am going to have a median without adding and dividing by 2. If the amount of numbers is even, you're going to end up circling 2 numbers, adding them up and dividing by 2, or figuring out what's between the numbers. So let's see, I got 15. So I could have 7 numbers, 1, 2, 3, 4, 5, 6, 7 numbers right here. And I could have also 1, 2, 3, 4, 5, 6, 7 numbers going this way. Now, you know what's the amazing part about this problem? The amazing thing about this problem is that now we have a median. Let's take a look at the other problem, the problem that we had before. In this, oh, I erased it, okay. In this problem right here, the median, okay, the numbers are not in order, but we had the 85 and the 85, and the median was in between. So then, this line, the median, divided the sets like this. You see that? You see the difference? The median is between the two numbers. In this one right here, we have a median. So look how the numbers get separated. I don't have, the separation doesn't occur between two numbers. No, on the contrary, the separation happens on the side of the number. Alright then, so that's so cool. So let us now find the median of the other number.
Is that the same as this?
So, let us do this. So the median, quartile number 2 here was?
292.
Excellent. 292. So now let's find the median right here. And how am I going to do it? Just count how many numbers we have. 1, 2, 3, 4, 5, 6, 7. Good day again. The amount of numbers is odd. So how many numbers am I going to have on the sides if I have 7 numbers?
3.
3 numbers. Very good. So right here and right here, I just found my first quartile. So my first quartile is 145. Now let's find the median right here. 1, 2, 3, 4, 5, 6, 7 numbers. So you know what to do. What would be the median right here?
407.
Right. The median is 407. Cool. Do I have all the parts required for me to construct a box and whisker plot? Yes, I do.
Yes, sir.
Thank you very mucho. So, once again, for these purposes, I need to erase these numbers, which you already have here. Wait, mister, oh my God, you erased it. No, just pause it or rewind it. Hey, good. Okay, so for the purposes being, minimum was 120, maximum was 452, quartile number 1 is 145, quartile number 2 is 292, and quartile number 3 is 407. I ran out of colors.
Blue.
Blue? Okay. 407 is blue. Yes. Okie dokie then. Let me start. They say using an appropriate scale. They don't want this to be perfect, but they do want you to use an appropriate scale, a scale that makes sense. For example, what is it that I should not do? I should not write the following. 120, 145, 292, 407, and 452. You can't do that. You cannot just write numbers like that. Just because you have them here doesn't mean that you're going to write them like that. No. So this is how a scale works. A scale has the same amount of numbers from each interval. So, how am I going to construct this? I guess I have a very easy method, okay? For example, the lowest number is 120. The highest number is 452. Alright? And I'm supposed to plot 1, 2, 3, 4, 5 numbers. Okay, so what I'm going to do is this. I am going to take 452. Of course, that's not the way they teach it to you in school, but I'm going to take 452 and I'm going to divide by 5. And that gives me 90.4. 90.4. Alright, that's close to 100. So you know what? That's exactly what I'm going to do. I'm going to make them look, I'm going to go from, I'm going to make each of these be worth, let's see, 90, 20, how many dots we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Oh, wait. So then I got a better idea. Let's take the 452 and divide it by 21. That tells me how much each of these is going to be worth, each of the hash marks. 21 it says. Okay, so I'm going to go with 21. And you know what's even better? I could go with 25. So I'm going to go with 25. So the first one is going to be 25. 50, 75, 100. Okay, unfortunately the ink right here is too thick, but with your pencil try to make the marks as small as possible so they fit in there. So 25, this is 100. So 100, then this is 125, 150, 175, 200. So this is 200 right here. Okay, 200. 1, 2, 3, 4, that's 300 right here. 1, 2, 3, 4, that's 400 right here. Okay, let me see if I can make this a little larger. No, it didn't work. Okay, let's go back to where we were before. Okay, so that's what we have, right? Okay, 400, and this is 1, 2, 3, 4, this is 500. Okay, now you see I'm consistent with my values. So basically, this is a good scale. This is what we call a good scale. All right then. So let's start plotting the points. Okay, the first thing I do is the median, 292. Okay, if this is 300 and this is 275, then this around here should be 292. Make sense to you guys?
Yep.
Okay then. Now I'm gonna head towards my first quartile. My first quartile is 145. So if this is 100, this is 125, this is 150, then 145 should be around here. See that? They don't want it to be perfect. You understand that? If they wanted it to be perfect, they would have given you values for perfection towards your accuracy. They would have given you the values right here on the graph. And if you don't do it the way they want to, then you get it wrong. But here, they're not giving you specific numbers. You're creating your own scale. I told you what not to do. So, okay then. So this is 145. Cool. So let me connect my points right now. Awesome. Now let's go towards my third quartile, which is 407. Well, this is 400, and this is 425. So 407 should be around here. Ah, nice. Okay, now what else? What else is that I need the minimum? The minimum is 120. This is 125. So 120 should be around here. So watch this. I know, it looks weird, but that should be around 120. You guys have a pencil. You should be more accurate. So you should get closer to the 120. Maximum is 452. Okay. 400, 425, 450. So 452 should be around here. Right? So 452. Okay? Now, not only that, for more accuracy, okay, I never encountered any problems with this, but for more accuracy, do me a favor, because sometimes the people who grade the regions, they might say, oh, do they want accuracy? Do they want this? Do they want that? No. To clear all doubts, you know, to get it out of the way, do this. 120. 145, and this I just came up with that because I was gonna leave it with the problem like this. This is 292, this is 407, and this is
452.
452. Okay, that will explain to our little readers that you know what you're doing. Okay, that you mean business. That you just didn't do all this work out of randomness. All right then. So with this, let's move on to our next problem. Okay. Problem 59. Using the line provided, construct a box and whisker plot for the 12 scores below. Right now he says 12. That means that is an even number. And as an even number, the median is going to be between two numbers. Now, are these numbers in order from lowest to highest?
No.
No. Okay. Now, do you have the numbers already?
Yeah, right there.
Alright, so then let's find the numbers. The first number is 10. The second number is 16. The third number is 19, 21, 26, 28, 32, 38, 40, 42, 57, and 65. So let's see now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Of course, I did it faster than you because I got my minions here helping me out, right? My pupils. So, alright, so we got these numbers. We need to construct a box and whisker plot. The same as the last question, but this one is only worth 2 points. Why? Because they're just asking you to construct a box and whisker plot plus another question. Alright, so let's see. What is the box and whisker plot business all about? Finding what?
Minimum.
Medians.
Median.
It's all about the medians, right? You hear mean, mode, forget about it. It's not that. It's all about medians. Now, what are the parts of the box and whisker plot? Then we have minimum. Is it visible right there?
Yep.
Okay, minimum, maximum. We got quartile number 1, quartile number 2, quartile number 3. We can see this?
Yep.
All right. So let's find the first median. And remember, the median of medians is quartile number 2. So that's what we're going to do. We got 12 numbers. So if I was to cross out, I'm going to end up with 6 numbers there, 6 numbers here. Look. 1, 2, 3, 4, 5, 6. Okay? And then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the median is between these two numbers. Okay? Notice now that the separation of numbers occurs between two numbers, as opposed to when we did the other problem that the separation occurred on the side of a number. Alright, so now that I know what the median, well, I don't know what the median is, but let's see, 28 and 32. You add them up and divide by 2, or use your common sense and say, well, what's between 28 and 32? 30. So then my first median, which is the quartile number 2, is going to be 30. Alright then. From that, I take away, I go on the road, I separate these things into 2 groups. Okay? As to take the shape of a box. Now I'm going to find the median here. Let's count how many numbers. 1, 2, 3, 4, 5, 6. It's even. Therefore, the median is between 2 numbers again. Well, if you have 6 numbers, halfway is 3, right?
Yep.
Right here. You add them up and divide by 2. Or as I said before, use your common sense. What's between 19 and 21?
20.
20. So my first quartile is 20. Awesome. Now to find quartile number 3. Again, 1, 2, 3, 4, 5, 6 numbers. So the median is between 40 and 42. What's between 40 and 42?
41.
41. So my my third quartile is 41. Alright then. What is my minimum?
10.
Excellent. 10. What is my maximum?
65.
65. I'm gonna put it right here. All right. So minimum is 10, quartile number 1, quartile number 2, quartile number 3, maximum. Do I have the required parts to construct my box and whisker plot now?
Yep.
Excellent. So that's exactly what I'm going to do. So once again, I hope you have copied the numbers in order. I hope you have copied the information here, because I have to erase them in order to construct my box and whisker plot. You have pencils, so you could actually write the numbers on the blank space, but my ink is too thick. All right. Erase, 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 erase. Cool. Do I have to provide a scale? Yes, because they only gave me hash marks. So what am I going to do? Count how many hash marks I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 10, 11, 12, 13, 14, 15 hash marks. Okay, and my largest number is 65. So, I love this new calculator. Thank you, Pedro.
You're welcome.
What is it again? I forgot. 65 is the largest number. And how many hash marks we have?
15.
15. So what do I get? I get 4.3. That means I can go by fives. Right? Makes sense?
Yep.
We go by fives. Okay, so let's go by fives. So this is going to be 5, 10. Let me see, do I have? No.
Yeah.
10, 15, okay, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70.
Boom.
That's it, right?
That's
Done.
That's it.
Awesome. Okay. So now let's construct our box and whisker plot. Let's see. The median is 30. So I'm going to go to 30. Oh my God, this is going to be an OD, nice, beastingly, awesomely, superb, whatever, box and whisker plot. Alright.
Swagtastic.
Swagtastic. It's going to be radical, dude. Alright, so we got Q1, which is the first quartile. I'm going to go to the first quartile, it's 20. Oh my God, beautiful. Oh, awesome. That's why it's called Beker's time. But now it's going to be Becker-Prater's time.
Booyah.
Booyah. Where do I go again? Oh, my third quartile is 41. This is 40, so 41 should be somewhere around here. Okay, you could do it a little with a little more perfection. Okay, I really tried. I did my best, but it's too thick. All right, so I go here. Okay, my box. Hey. And now I go towards my minimum. What is my minimum, guys?
10.
What the hell is 10? Right here?
Yes, sir.
And now my maximum is 65. Right here, right?
Right in between.
Okay. Did we do a great job or what?
Ta-da!
Ta-da! Okay. So we have now, oh sorry guys, yes. Apologize. So this is your box and whisker plot with all the elements required. So let's see, before I give you a little time to copy. That means you pause it. And now let's move on to, oh wait, hold on a second. If I just leave this the way it is, I only get half the points. Because I just happen to do what you always do as students. Forget to read the whole problem. So determine the number of scores that lie above the 75th percentile. 75th percentile, 75%, but what the, oh my God, the box and whisker plot, quartiles, quartiles, quarter. How much is a quarter?
25 cents.
25 cents. And if we're talking about quartiles, talking about percentages, well, what percent is a quartile?
25%.
25%? Oh, okay. Now it's good. Now it's good. Okay, so fine. Let's do this. 25%, then this is what? Second quartile. So how many in 2 quarters?
50%.
And then this is? Okay. The number of scores that lie above this. Say it again? Well, let's count. Oh my God, I need the numbers in order.
Above 41, right?
Above 41. Okay, so above 41. 1, 2, 3. Oh, that's it, right?
Yep.
Okay, so this is how you write it. 3 scores lie above the 75th percentile. Okay, took me long enough, but we did it. Thanks to Mr. Prado right here. Alright, thank you, Mr. Prado.
You're quite welcome.
Okay, now we move to problem number 60. Alright, woo! The hardest part is gone. Now comes the easy part. What is the range? I didn't teach you about this. Oh my God, I have to teach you about this. So okay, what is the range of the data presented in the box and whisker plot shown below? Get ready to acquire a new skill. The range is nothing more than the maximum minus the minimum. Thank you very much. So let's see. The question is, what is the range? Okay, what is the maximum value here?
75.
75. Minus what? Right, the minimum. What is the minimum? I have no idea.
15.
15, let's see, how does it go? 5, 10, 15, 20, 20. Ah, it goes by 5s. So 1, 2, 3, so you said what?
15.
15. And what is 75 minus 15?
60.
60. And the correct choice is...
That was easy.
Oof. Off. Good. Let's move on. Okay. Now, it says, the box and whisker plot below represents the result of the test scores in a math class. Okay. What do the scores 65, 85, 100 represent? I don't know, but let's see. Where is 65? Right here?
Nope.
65, 70, 80. Oh, okay. They go by tens. So 65 is right here.
Yep.
Ah, okay. 65 represents, okay, what is it that we call this? Q1.
1.
First quartile. Okay. What else? 85? 85 is around here. First quartile, second quartile, third quartile. Okay. 85 is my third quartile. And 100. It ends at 100.
Max, baby.
Max, baby. All right. So 100 is the maximum.
Maximum.
Okay. So that's it. Quartile number 1, number 3, and the maximum. Quartile number 1, number 2. Oh, good day. Awesome day. We getting it, right? All right. So let's move on to question 62. Alright, see, these are easy questions. Okay, fine, I'll let you see my face for a little while. Okay. So, 62. What is the value of the third quartile shown on the box and whisker plot below? What do they want? What do we have to Keep an eye for the important information. This is what they want.
Third.
Well, what is this?
Min.
What is this?
Q1.
What is this?
Q2. Quartile 3.
And the third quartile is also, just in case, and you know what, let's write the names. We did it on the last, the last 2 episodes of how to pass the algebra regions. Q1 is called the lower quartile. Q2 is called the median. Q3 is called as well the upper quartile. Okay? These are other names given to these quartiles. So now the question is this: what is the value of the third quartile? I have no idea because I just wrote over it. Okay, let's see. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, good day. The third quartile is 10. Okay, that was Q3. Okay. Was that easy or what? Now, let's go on to question 63. The box and whisker plot below represents students' scores on a recent English test. Question: what is the value of the upper quartile? Oh my God! Look, we were just discussing Q3 called the upper quartile. So we know what we're talking about. They want the value of the third quartile. First of all, let's figure out the scale. 60 and then 1, 2, 3, 4, 5. Oh, okay, it goes by twos. Look, 60, 62, 64, 66, 68, 70. So it goes by twos. So the upper quartile.
Yep.
So what is it?
84.
Nice. Okay, then now let's go on to question 64.
Is that the last one?
I have no idea. Is it? Is it the last one?
Oh no.
Just kidding.
No.
Just kidding.
Oh, you got me, you got me, you got me.
My bad.
Okay, let's do this. Thank you for moving all my problems around, and I don't know where I'm at right now. Okay, which problem was that again?
64.
Okay. Let's see now. Okay, we're back in business. So let's see now. And now we have a new student. Thank you very much. So, 64. The box and whisker plot below represents the math test scores of 20 students. Alright, I don't care about that. What percentage of the test scores are less than 72? Less than 72. I know that this goes by twos. I knew it already. So, less than 72. This is 72. And do we know what quartile is this?
Quartile 1.
Quartile number 1. To get from 0 to quartile number 1, which is a quarter, how many cents do you have to go through?
25.
25. So the answer is less than 72 is 25. There you go. That wasn't that difficult, right?
Nope.
Now, let's go over question number 65. Is it visible?
Yep.
Okay. Just in case, okay? We're checking. The box and whisker plot below represents the ages of 12 people. I don't care about that either. What percentage of these people are age 15 or older? Alright, first of all, let me find 15. Where is 15?
Q1.
Oh, right here? 15. What do we call this again?
Q1.
Quartile number 1. Very good. Q1. Okay. And they want 15 or older. They want all these people right here. Well, to get to 15, how much percent do we have to waste? We got from 0 to quartile number 1. A quarter?
25.
What is the percent? Ms. Pantojas, what is the percent? A quarter?
25.
Excellent. Mucho bien. Okay, so it's 25% to get to 15, but they don't want 25%. They want the rest. So what could be the rest of the percentages?
Miss Pantojas?
100% minus 25%.
There she goes thinking mathematically again.
75.
Oh, thank you, 75%. All right, because you are OD, girl. You're awesome.
D
Okay.
nice.
Say it again.
OD nice.
She's OD nice. Okay, question 66. The box and whisker plot below represents a set of grades in a college statistics class. Good, I read it. It doesn't help me at all. Let's see the question. Which interval contains exactly 50% of the grades? I don't know. Exactly means at one specific location. 50%, 50 cents. What am I referring to? Quartile 1, quartile 2, quartile 3? How many quarters make 50 again?
2?
Anybody? No? How many quarters make 50?
2.
So 2 quarters, 2 quartiles, second quartile.
2?
Quartile number 2 it is. So right here with a colorful marker, this right here is 50%. I still don't know what it is. Okay, let's see. Which interval contains the 50% of the grades? 63 to 88. 63 to 88. 63 to 95. 63 to 95. Ooh, no, that's too much. 75 to 81. 75 to 81. No, from 75 to 81 is just 25%. So it goes from quartile 1 to quartile 2. 75 to 88. 75 to 88. Is this 50% right here? Yes, it is. Yes, it is. It's 50%. Because this is the other 25%. Okay, 25, 25. I didn't know the answer. Now I know it. Thank God. I would have been embarrassed if I didn't do that. Let me get rid of that problem. Let me go to an easier one. Woo! It's too big. It won't fit. So let's see now. It fits now?
Of course.
Thank you. Okay. Oh, sorry.
The problem.
The problem. We're talking about the problem here. All right, 67. Number of tickets sold in the hundreds. Okay, so you read the problem. It doesn't give me any important information. Let me read the question. Which conclusion can be made using this plot? Okay, so I guess I really have to read the problem now. A movie theater recorded the number of tickets sold daily for a popular movie. Okay. During the month of June, the box and whisker plot shown below represents the data for the number of tickets sold in the hundreds. Movie tickets. You see, I didn't even have to read it. All right. The second quartile is 600. Question to you. Is the second quartile 600? First quartile, second quartile, is it 600?
Nope.
Yep. The mean of the... whoa, wait. When I first started explaining to you on the last episode on how do we pass the regions, what did I say about box and whisker plots? They are all about what? Me. Say it again?
Me.
No.
Means.
No. Box and whisker plots are all about, exactly guys, medians.
Oh.
Medians. Medians and medians. Let us go back here when we did a problem. Look. And We did. Did we ever find the median of something? Let me see. Oh, oops. Let me see. Okay, here. Median, median, median. Okay? It's all about medians. All right. All right. So, let's see now. The range, okay, the mean. They talk about mean. What did I say when you see the word mean and when they're talking about a box and whisker plot?
Median.
Exactly. So this cannot be an answer right away. Number 3. The range of the attendance is 300 to 600. 300 to 600. Is that the range of the attendance? Guess what? The range is not an interval. It's not from to. The range is a number. Maximum versus minus minimum. What are my balls doing here? Here. Maximum minus minimum. So it's not an interval. It's just one single number. All right. So this cannot be the answer. Of course, yes, we know that the answer is 4 because we just cancel out 4 choices. 25%, no cell phones here, miss, I'm sorry. No, okay. 25% of the attendance is between 300 and 400. 25% of the attendance is between 300 and 400. Well, hello. To go from the first quartile to the second quartile, you have to increase how much percent?
25%.
There you go, 25%, making our winner. Choice number 4. All right, let's go on to question 68. Oh, my bad. I think we're done with the packet. No problem. See you in the next episode of How Do I Pass My Algebra Regents? Thank you.
Good night.